Okay, let's start. Questions? Questions? Okay, so your current assignment, which was due yesterday, called for exceptions and undo. And those of you who attempted the extra credit were supposed to learn that stuff on your own. So some of you may have actually gone and looked at exceptions. So how many of you have actually done some exception handling either through this assignment or before? Okay, some of you. Okay, so hopefully you'll still learn something to do with. We'll see how far we get into exceptions, and if we get far enough, you'll also learn about iterators if you don't know about iterators. So exceptions have to do with error handling, right? I mean that's kind of obvious from what you know about exceptions. Can we qualify a little bit more? So what, exceptions, I'm going to take 2 classes, if not more. So we're going to spend some time on it. And, error handling, you guys have been doing throughout the semester. So what is it that you need to know more to understand, to deal with error handling? And that is something that exceptions may be offering. So, let's look at errors first. Errors and mistakes. Okay, so and mistakes are errors, so we can always go in that recursive way. But what kind of errors do you have when you write a program? If you were to classify them, how would you classify them? Maybe that will help us with exceptions. Okay, Jay? So syntax errors, and those errors are caught when? Compile time. And exceptions would be errors that are caught at? Okay, so a little bit more we know. So these are runtime errors. Can we classify runtime errors into different kinds of errors? Austin? Okay, so we can type errors. And we can say array index out of bounds exception, null pointer exception. So exceptions seem to be typed things. And types implies classes and or interfaces. So exceptions, in fact, are classes. That's how Java designed it. Java did not make them have interfaces. We can have in our exceptions interfaces, but the ones it defines don't have interfaces. Okay, so these are classes. And can we divide these types of exceptions into categories? And that's exceptions. Okay, so let's not get into exceptions too quickly. Let's just talk about errors in general. Okay, so errors can be runtime errors and compile time errors. Runtime errors are what have to do with exceptions. Now let's just go back to errors in any language. And they can be different kinds of errors, but can you classify these various kinds into even broader categories? Think of your program. What kind of errors have you had to deal with that manifest themselves at runtime? Andrew?
Recoverable and unrecoverable.
Okay, so you can say recoverable or unrecoverable errors. So if you get a null pointer exception, is that something you could recover from? No? Okay. Recover meaning what? Once it's recover means at runtime or change it later. Okay, so recoverable could be that while the program is executing, you recover from it, or it could mean that you could go and avoid it in the next iteration. Okay, so null point errors are probably errors you could avoid in the next iteration, but in that particular execution, you probably couldn't recover from it. During?
So there are errors that cause your program to fail versus errors that just cause it to return the wrong thing, like logical errors that cause it to have the wrong output.
Okay, so that's kind of recoverable versus non-recoverable. So recoverable errors are errors probably that cause some output, maybe even an error message. And unrecoverable errors are ones that you throw up your hands. And if you throw up your hands, how does the program executor, the TA, know you have an error? They get some kind of message. Okay, so there can be errors that the programmer handles, and errors that you go and let the programmer does nothing with. and then when the programmer handles the errors, they could recover from it, or they may not recover from it. Okay? Let's talk about fault finding. So the errors could be caused by whose fault it is when there are errors in the program. The programmer's, or it could be somebody else's fault also. The programmer, and who's the other? Austin, who's the other? The end user. Have you seen those errors? They may enter the wrong token. They may enter, and I keep telling you guys that don't even worry about that. Okay? But in general, the user could be causing the error. So there could be an error in the program, or there could be some external agent that caused the error. The external agent could be a user, or in this world of what else could the external agent be besides the program and the user? So you're running one JVM, you're running one program. That program may not be at error. The user may not be at error.
The OS crashes.
Sorry?
The operating system crashes.
Okay, so the operating system, that could crash, or the hardware could crash. Okay? Things you trust.
Any other program is interacting with it.
Any other program that's interacting with it. In this world of internet computing, does that happen? A lot. Okay, so this program has been written to accept some format of data from the end user, some format of data from another program. So that's an external error. Okay, that's going to be very important in the design of exceptions. Okay, so exceptions have to do with error handling. They have to do with custom error handling. That you don't just throw up your hands. Maybe you go and give a nice error message, or maybe you even recover from it. Okay, and the error kinds could be internal errors, okay, off by one. Okay, so you're going through a loop and you don't know whether to terminate at length -1 or length -2 sometimes. So you have these errors you get quite often. Or external errors, which could be user input, file system, okay. So one program could have written to a file that another program is reading from, okay, and that could cause an error. Okay, you'd ask Microsoft Word to go and open some file it doesn't understand, a Java file. Well, it can actually open a Java file, but that may cause problems. Okay, other distributed programs. So, I've taken a very casual approach towards errors in some sense in this course, right? I mean, when are we doing exception handling? The last week of class almost, right? And I keep telling you guys, don't worry about errors. When I do the code in class, I just don't even talk about errors. So how important is error handling? I seem to be implying it's not important, right? Yet I didn't quite let you go without covering error handling. So, yeah.
Some programs that can be used for hugely important things, like I can think of like planes, for example, like these programs, and you don't get errors in that. The plane will like crash.
So some programs, you want to catch errors and write the plane, right? Whereas Microsoft Word, who cares? You just lose 10 days of work or 1 day of work, or I don't know, How much does Microsoft Word cost? How much does the plane cost? Okay, so, when people complain about Microsoft, you have to see what you get. But there's an interesting, I don't know if this is a true story or not. A bunch of software engineers were asked, how many of you would be willing to enter a plane if you knew that you had written the software for it? How many of you would do it? So one person said yes. And the rest of the people said, oh, you're very confident. He said, if I wrote the program, the plane wouldn't even take off. So yes, those guys really, really have to worry about a lot. But what about a good old program that you write, a Word? Sure, the user may get annoyed, they may lose work. What else could go wrong if that program is erroneous? Something really bad. Yeah. They can use system resources, and so that will just waste time. Could it be even worse than that? A lot of security problems are caused by errors. Okay. When something bad happens, when the user enters something bad, you just assume it doesn't happen, right? Well, what might you do, especially if the language is not very good? The user may enter a long string, and you just allocated this much space for it, and the user entered this longer string. Ideally, the language should go and catch and say, okay, this won't fit in this array. But some languages are very blasé about things and say, oh, we'll just go over the array and go to the next array and write it down there and go to the next array and get to the next array structure. And the hacker can go and write interesting things into your memory and then maybe even execute that stuff as code. So what they entered was some code that the program executes, and a lot of security problems occur with it. Okay, so so some people like So when I was at Purdue at one time, and I used to grade operating system exams, and the two of us would grade the same exam, and one of them was a security person, and I wasn't. So I would look for the general case, and you say, oh, they didn't get the error case, so what? 5% off. He would only look at the error case, and he wouldn't even look at the other stuff. And he said, that would cause a crash. So, it's different outlooks. And security people really, really care about the error handling. Okay? So it is important, even though we are looking at it at the end. Okay? And you want to study more about this stuff, do take security courses. And we have excellent faculty members in security here also. Okay. So error handling is important. Okay? But we have gone through this whole semester without studying exceptions, and some of you have done the extra credit that required you to go and look at scanning errors and parsing errors. And most of you who've done that part have done it without exceptions. Okay? A lot of languages do not have exceptions. Yet, people who write in those languages do error handling. So now we are going to tie error handling to exceptions in Java. What do you need to know more, or what have you missed when you were doing error handling that could be bettered through language design? And if you know exceptions, you can obviously use your knowledge of exceptions. So why have something special, some special concept called exceptions to do error handling? You've got ifs, you've got prints, you can do anything, without exception handling. So what are we going to gain by having this special concept of exception? Because we'll see there's a lot of rules here. Andrew?
So you react to different errors differently depending on what the exception they throw is.
So you're saying that you might want to react to different kinds of errors or in different places?
Different kinds of errors. So you have something where you could have like a null pointer or an IO exception, so you react to IO differently than null pointer.
So you want to handle different kinds of errors differently, right? Yeah. And if I didn't have exceptions, I couldn't have typed errors. Were you going to raise your hand? Yeah.
It's easier to read than
Okay, so whatever Java does provide, and you are familiar with some of that, you think that is easier to read than if statements. And Andrew's thing is that we need types of errors. So that's good. I mean, exceptions could be just these type classes, right? So we want to distinguish between null pointer exception and array index out of bounds exception. And rather than defining, if I didn't have types in a language to describe these exceptions, what else might I have? Have you guys dealt with some other language that classified exceptions based on some other criteria other than types? Have you ever seen an error message from the system saying something bad happened, and they indicate what happened, the bad, by not a name but by a code? Have you seen that?
Yeah, Windows does that all the time.
It does? Okay, I guess it does. It still does? It used to? Okay. What else does Windows do when something really bad happens?
Blue screen and death.
Blue screen. Anybody programmed in C? What is the equivalent of blue screen in C? Fault. And and when there's a fault, what kind of aids does C give you? A core dump. It says, here's the whole memory, you figure out. And I mean, that's what people did. Okay? So the first time I saw the core dump in C, I told my partner, you program, I'll just watch you program, So it was not a pleasant experience. So rather than having these codes, it could have nice names, and these names could be types. Okay, so that's one thing we get. We get these types from exceptions, and we get these try catches that you seem to be familiar with, and those happen to, and you're saying they're easy to read than if else. So that may be true. Anything else that you guys, yeah, Andrew?
Also, if you get to an exception, then you can have it so it won't run any other code that relies on whatever through that exception. So if you get a null pointer, it won't try to access the other things that they access that same thing that happens to be null. You have to retry.
Okay, I'm not sure I followed that. So you.
So like, or if you're like reading input, if you get an IO exception, it will try to say do something else with that input because it failed.
Okay, so we know that when we did scanning errors, okay, so when the user had an illegal token, you could kind of recover from that, right? You could go to the next token. But when you have a parsing exception, the moment you have the first error, you're going to get a cascade of errors after that because who knows what's going to happen afterwards. And the similar thing, that once you get a null pointer exception or you get this IO exception, you probably don't want to go any further, okay? Because who knows what bad things are going to happen. And we don't want to let this person go and input stuff into your memory and cause havoc, okay? So there's a notion of type exception. There's a notion of this, some other construct rather than if then, which is try catch. And there's a notion of stopping execution and not going any further in some scope and saying, look, we are not going to, this is just going to be dangerous to execute afterwards, okay? So you guys are getting a lot of that stuff. So error handling can be done without exceptions. And, you know, when you said it's easy to read, you're getting into software engineering principles, okay? And besides readability, what other software engineering principles are there? If I was to ask you in the midterm, enumerate all the things you've learned, give them names, the software engineering principles. You might say readability and, sorry, reuse. And reuse comes from, yeah, modularity. And modularity is separation of concerns. So separation of concerns is sort of a broader principle, and modularity is the one way to do it. And these programs that dump code, typically they don't dump code because the language designers didn't know better. The language designer were trying to go and make efficient programs. Think programs that really ran fast. C is what you use to make things run fast, and fast is a good software engineering goal also. Okay, so you want easier to program somehow. You want efficiency. That's a good goal, and it's a trade-off sometimes. Sometimes what is easier to program is not very efficient. Okay, if you programmed in machine language, it'd be more efficient if you were a really good programmer. Okay, so you want to try to have both of these goals. You want separation of concerns, and what could error handling and separation of concerns have to do with each other? I mean, why am I talking about separation of concerns in the context of error handling? What are the concerns? Yeah, Zach.
Because if you use exceptions, that brings in something else to deal with errors with exceptions. Whereas if you have your program running, doing whatever it wants to do, and dealing with errors.
Okay. So the thing is that errors is another concern. And you might want the error concern and the non-error concern to be separated. So that when I grade the students' exams, I can just look at the non-error part, and my security expert can look at the erroneous part. Okay, and that's why I've not done errors before, because there were too many things I was trying to focus on something else other than errors. So I focused on that rather than errors, and now we'll just talk about errors. Okay? So non-erroneous code and erroneous code, and that is why perhaps these try catches are easier to read than the if then else's. Okay, so we'll take almost the simplest possible program and dissect it to death now using our error checking hat, the security hat. Okay, so what could go wrong in this program? the user does not provide an argument, right? And we know how the arguments are provided, and if we don't do that, we'll get, if we provide the argument, this is what we'll get. We'll get hello world printed out. Okay? Can you guys see the bottom, by the way, from the back? Can you guys can also see? Okay, so if the user does not provide an argument, given that program we had earlier, what do you think is going to happen on the screen? What will you see on the screen? Are you going to see a blue screen? No. So, an error was made. When an error is made, and the program is not handling it, the question is, what is the default handling? Okay, so the default handling is A, that it will tell you the kind of exception, and B, it'll exit the program, and C, where the error is, and it'll tell you which line it occurred in that main method, and will it tell you something else also besides where it occurred, in which procedure? Yeah. It'll give you the whole stack. Okay. So it'll tell you these three things. And what exactly is the error that occurs? Is it a null pointer exception or is there some other kind of exception? Let's look at here again. So if the user does not provide an argument, what goes wrong? Andrew? Array index out of bounds. There will be an args. That args will have length of 0. Okay? So if there was no args, it would be a null pointer exception. But here we will get, so we get a type of exception, which is array index. We get to see the line also. And we get the trace of all methods in the call chain, or the call chain is the stack. So we'll see those two things. So this is the default handling. Okay, so without teaching you exceptions, by you just writing programs and Java dealing with the exceptions, you get some error message. Okay, now you can look at this and say the glass is half full. And the glass is half full. This is an excellent error report because what is the bad thing that could how could the error message be worse than this? None. Okay, that's one interesting thing. That it silently goes and fails. Doesn't even tell you something bad happened. Better than that is the code dump. And the code dump, how do you get the code dump? You get the code dump not when the error occurred, much later. Okay, because that error caused another error, and finally there was an illegal access. So what really happens is that when you go and say arg0, what does Java really do? Java says, okay, I know the location of args, the array. Now you're going in subscripting the array. I know you're going to the 0th element or the first element or the nth element. It goes and adds an offset to where args is stored. And it goes and tries to access that. Okay, that's what it does. So these other languages like C just do that. They say, okay, we assume you know what you're doing. You went and said args5. I'll just go to the fifth word following args. Okay? And no error message. Whereas the fact that Java did this means that Java was actually being very slow. It was doing, not very slow, but it was doing what's called subscript checking. Every time you go and access an array element, it goes and says, are you within bounds or have you gone beyond the bounds? And that is why it's harder to go and make Java programs fail in a bad way by hackers rather than C programs. Okay? So I spent some time in Microsoft, and while I was there, they had this big push on trustworthy computing, and basically it meant that replace C with C#, and C# is sort of nicer version of Java. Okay? It came after Java, so it cleaned up a little bit more. It's got getters and setters built into the language, and you can't go wrong in the syntax there. And they did it for all parts. I was sitting with the operating system group, and that group was revolting because they wanted to make things efficient, and so the kernel group did a program in C. So, but C# like Java will do this subscript checking. Okay, And that's why you got this error. You got this error because there was extra checks put in by the language saying, have you gone out of bounds? The bounds that were expected. Okay? So that's your glass half full approach. The glass half empty, what's really bad about these error messages?
They don't help the user at all.
So they're okay for the programmer when they're debugging. But the end user, they didn't enter an argument that says array index out of bounds exception. Are they going to go and find the run configuration and enter the argument? No. Okay? So understandable to programmer, but to not user. Okay? So that's what's wrong. Is write a better program, the programmer, and can say if args.length is 0, then specify a message and we can exit the program. Okay? Our program is not being graded by the grader program, so we can use the exit statement here. And okay, no exception. We didn't have, as programmers, have to know about exceptions. We just wrote this program. How can you fault this program now? Okay, so now let's go and put up. We all said very abstractly, here are the advantages of doing exception handling. In this concrete program, tell me what I'm doing. Tell me why this is not the best solution. Zach? Sorry?
There might be some kind of object that you can't necessarily print directly.
Okay, so you're saying that maybe print line, if that the error may not be printable by print line. As it turns out, everybody relies on toString. Print line does, Java does, so that's not, that's not quite the answer. Zach?
You'll get the error message if you add 5, 6, 7 arguments, anything more than 1.
Okay, so you're faulting. Okay, so you're saying you could do better error checking. You could check if args length is not equal to 1. Okay, let's assume that's a feature. That we let you enter 5 arguments and we just print the first one. Okay, that's true. But given the error that I am checking, is there a better way to do the same error reporting? Let's just, there I'm not even checking for that particular error. Andrew?
It checks if there's the error, then does instead of doing it and then only handling the error if it is actually a problem.
So you're saying it checks for the error first and it does the correct thing later. You're saying should we have reversed that? Should we have done the proper thing, the expected thing first and the unexpected thing later? Is that what you're saying is the fault here?
So it has to go, it checks the error condition before it does any execution. So I guess I'm saying that try catch make more sense. Basically, so it runs it, and then if there's an exception, then okay, they have this problem, let's go deal with this.
So in try catch, the check has to be made one way or the other before you execute the code, right? The question is, does the erroneous code come first, error handling code come first, or does the non-error handling code come first? And you're saying with try catch, the non-erroneous code comes first, and here the erroneous code, the error handling code come first. Does that make it less readable somehow?
You don't really know what's going wrong. It's going okay, there could be an error. Where's this? What's keep looking to find what.
So you have to look to find which the error part is, which is non-error part. In this if, you have to see that, the then part is the erroneous error handling part, and the else part is the non-error part. So I, as somebody who doesn't care about errors, have to look at every if to figure out which part should I look at. To look at.
On top of that, this is expecting an argument. So if you pass an empty string, now you have to do another check.
Okay, so you're saying that one, but the checks. So you again, like Zach, you're complaining that I'm not doing enough error checking. Look, I'm doing some error checking. Given my view philosophy, that's pretty good. Okay.
If you wanted to change how exactly your program takes the error and does what, like, prints out a line or something, if you have more than one thing where you can just select to go into your program that actually is supposed to do something other than just error checking and fix every instance where you're trying to catch an error.
Okay, so you might have an if, else, and you've got to go through all the else's to figure out which one I'm interested in. Okay, we've got that. Okay, that's good. That's excellent. What about efficiency? Is this program slower or faster than the program I wrote earlier? Why is it slower? Because I'm doing this checking. And I'm doing this extra checking. Java already is checking here. This is, it's checking. Whenever you do arg0, Java has put some code that's compiled that goes and checks whether the value is within bounds or not. That is why you got that exception earlier. We are doing the check twice. That's very important. Okay? So through exception handling, not only will we get something that's more high level, easier to program, but also something is more efficient. That doesn't happen very often, by the way. Huh? You have your cake and eat it too. You get both programmability and efficiency by what we'll do. Okay? So this is not what we want, ideally. Okay? So we've got this part, we've got this part. One part is the error handling code, the other is the non-error handling code. And we don't know, this undifferentiated for the reader, which all of you have, you sort of have latched onto that and agree with it. And you may want to ignore errors on first pass, or you may want to only look at errors on first pass, depending on who you are. And Java checks for subscript error already, compile code, and we are doing the check again. Okay? So these are all the problems that we want to solve through something new, a new kind of construct, and that construct we are going to call. Okay? And, this code for many of you is not foreign, and even for the rest of you, I threw the stuff in the very first day or second day of class saying, let's try catch, and this is kind of how it works. Let's try to dissect this and understand it better. So I've got two parts here. Clearly, this part is the part that assumes no errors, and this is the part that handles errors. Okay? And we've got these curly braces here to separate the first part from the second part. Okay? Now, why the word try before this piece of code? Austin?
Well, you're going to try to print out the first element in the arguments array, and if it fails, you're going to
Okay. So when you write your code, you have different degrees of confidence about what you're writing, right? And try means, I'm really not sure. Yeah.
Yeah, if you're not committing to it, then you can recover from a potential error.
So you're just saying, okay, I can certainly walk on this, big surface, but you ask me to walk a tightrope, and I'll say, I'll try. And
you don't have to do the check every single time you do anything, so you don't have to check.
okay, so you're telling me now why this is good. First, I'm looking at the syntax. Okay, and then we're getting into semantic, which is the more interesting part. Okay, so try means, look, I'm doing something that is potentially full of errors, and I might fail. Okay, I might fall down, and if I fall, I want a safety net. Okay, so you are not doing just this ordinary walking. You're walking with a safety net, and this is your safety net. Okay, that's sort of the analogy. That's something to catch you. Okay, so this is the try, this is the catch, and this is the analogy. Okay, now the semantics. So are we doing less error checking now? We went and separated the erroneous error-free code from the error handling code, right? So that we got that. How did we get performance?
It seems as if the catch will have a subscript checking to then process narrows down.
Okay, so basically what you're doing is you're saying, Java, let's go and cooperate on this checking. I know you do checking, right? That's how I got this exception. When you do the checking and you find something wrong, don't decide on how you're going to handle it. You just do the detection. I will do the handling. Okay? And when I do the handling, please tell me what kind of error you got, because you're good at catching all kinds of errors. You'll catch null pointer exception, you'll catch array index or bound exception. I want you to just go and worry about detection. Handling I will do in a custom way, because in my case, this array index out of bound exception means that my end user did not go and do the right value. So I would go and report a proper message, and I will use your handling to do that. Okay? That's what it really means, that I've caught your error. Okay? And something about the error is indicated in this particular variable, which we are not even looking at right now. We kind of know what the context is, so we don't bother to look at this value. Okay, questions?
Why is system not out of minus errors?
This one just goes, with rose-tinted glasses. Everything will go fine. And that's what you do in this. It assumes, here you put on the hat which assumes that everything will be fine. Here you put on the hat which says, oh, something could go wrong. So errors can happen here. You're just not bothering about them. So try-catch separates regular and error handling code. No extra subscript check. Okay, that's very important. Exception handling, exceptions really make your program faster. Okay, that was a very simple program. Let's try to make the program a little bit more complex, okay, to show the complexity of exception handling. So now I'm entering in my argument not a string to be echoed, but the number of strings that are to be echoed. And the strings that are to be echoed will be entered on the console. Okay, so we are going to bring in two forms of input. One is from the arguments, the other is from the end user. Okay, so I said, I ran the program. I said I'm going to give you two arguments, and then I gave it the first argument. I'm going to give you two strings, and then I gave it one string and it echoed it back. I gave it another string and it echoed it back. And since it expected only two strings, after the two strings, it went and terminated. Okay, that's my program. The goal is that you enter this number and then you go and enter so many lines. What all could go wrong here? This is my complex. Andrew?
You give a negative number.
Okay, you could give a negative number, or you could give, do you have to even give a number? You could write hello world here. And you may not even give an argument, right? And supposing you have, okay, so errors, user may enter no argument, user argument may be a non-positive, I should have said a non-natural, natural numbers include 0, I keep forgetting. A non-natural, I guess, you guys remember? So natural numbers are 1 or more or 0 or more? Oh, really? That's why I'm confused. Okay. So I mean a positive number. And so I may not do that. Anything else that can go wrong after that? I've entered 2. Okay, so that's interesting. Let's go and handle the easier case first. What if I try to enter 3 strings? I'll enter the first string, I'll enter the second string.
You can't take the terminates.
It's terminated. Yeah. So what will happen in Eclipse if I start trying to enter the third string?
Nothing.
It won't.
Console, but nothing happens.
Actually, I checked it this morning. I didn't know which way it was going to go. It won't even let you enter. If the program is terminated, you can't enter anything into the console. Okay? So, may enter more than n lines? Not really. You can't do it. Okay? User may enter less than n lines. Now, this is going to be the interesting case. If the user enters 1 line and doesn't do anything after that, as Zach was suggesting, the program's just going to wait. Is it possible for the user to tell the program, I'm done, without entering some -1 or dot or something? Just tell in general, I'm done with input. Have you guys, anybody seen this in perhaps another context?
Did we just use a period?
Sorry?
We just period.
Yeah, so that's between you and the program, right? We go and tell the program, if I enter dot, I'm done. Is there a way for a user to just tell the program, I'm done with input, in a very general way? You could terminate the program, but then the program is also terminated, right? So can the user terminate input without terminating the program? As it turns out, I'll give you a hint. Reading from the console and reading from a file are considered identical, basically. From the program's point of view, there's no difference. One is a stream that comes from the input, another is a stream that comes from a file. At an abstract level, they're all streams. Supposing that program was reading from a file, and you didn't put a -1, you didn't put a dot. How does a program get to know that that the input is over? So there is in every file an end of file mark. And when the program tries to read that, it gets to know there's end of file. And so what program does, it keeps reading till it gets end of file. There is an end of file in console also. Okay, I don't know how to do it in Windows. It depends on the operating system and the programming environment. I don't know how you do it quite on the Windows machine at least. But in Unix, which is the machine I grew up with, you would do Control D. So the user would enter things and then they would do Control D, and that was equivalent to putting an end of file mark. Okay, so Java is ready for a Control D, even though I don't know what it calls Control D. I haven't been able to Google or figure out what it does. Okay, so that is yet another error that can occur. That the user might go and say hello world and then control and end of file, and the poor program hasn't got its input that it expected. Okay, so lots of things that can go wrong here. Okay. So user may enter less than n lines and then enter the EOF or end of file character. And maybe Java doesn't even allow it, because I haven't found a way to do it. But in general, in languages, that is something that that users can do. Okay, so what we'll do is just to things have become more interesting because there are more kinds of errors. But that's not the only reason why they become interesting. We're going to make things more interesting because this is a more complex program, and we're not going to do all the work in one main method. We're going to have the main method call two different methods, and then the question becomes, whose responsibility is it to do the errors? That is where a lot of issues arise in exception handling. That we decide that we're going to do error handling, we've divided the program into multiple modules or multiple methods, and the question is which unit should do error handling. Okay? If you call a method, does the called method handle the errors it detects, or does maybe the calling method handle the error that it's the called method detected? Okay, just as you can handle the errors that Java detected, a calling method can maybe handle the error that a called method detected, and how to go and have it always. That makes sense. So my program is the following. There's a ... here, means that I haven't told you everything. But my main method is all of these methods are going to be static methods in one class right now, just so that I can use less space. Okay, no, I'm not going to use instance methods in different classes. So my main method is going to go and first call number of input lines. Number of input lines is going to go and look at the args, do whatever it needs to do to return back a number that says how many lines are to be input. That number is going to be given to ECHOLINES, which is going to read input and try to read that many lines of input. Okay? So the division responsibilities, there's a main method, there's an ECHOLINES method, there's a number of input lines method, and now we've got to figure out how do we distribute error handling among these three methods. Okay? And at least the function of these methods, no problems? Yeah.
Is there a way to have two consoles acting on the same program?
Can you have two consoles for the same program? There's only one console. Okay, what you can do is try to create your own windows that behave like consoles, but otherwise there's only one. And why might you do that? Can you imagine having more than one console for a program?
Well, I think it could just cause a lot of problems doing that.
You think it'll cause problems or solve problems?
It's kind of like unsynchronized threads almost.
Hang on. When you have threads, do you want one console or multiple consoles? You're saying it's like threads. Threads are
Change the same like memory.
No, but if I have two different consoles, I've said this is your. Imagine having one thread running in one console, another thread running in another console. That would be good, right? They won't get intermixed. So in fact, I've added some facility to Object Editor that lets you go and output different things into two different console-like things. They behave like consoles. They're just something I created using Object Editor. Okay, so that's actually something I really miss. In fact, in Java, I can have a distributed program. I can have 5 JVMs running in the same Eclipse environment, and they all share one area. Even though they're different consoles, they share one console area. So again, you want sort of separate consoles. Okay, but in general, there's one console. Okay, that's called the standard input. It's both the standard input and the standard output. Okay, and you can always substitute the standard input with a file and the standard output with a file without the program even knowing about it. Okay, anybody done that with Unix or Linux? Just input redirection, you guys? Okay, I'm getting off topic here, but that's something you can do. Okay, so I'm just, but let's not complicate the problem too much. So we have our main method that does this. Any questions? Further questions about this? And my number of input lines is going to do this integer.parseInt arg0. It assumes that everything goes perfectly. That's what goes into the try block. And then it catches one of the possible exceptions, which is the array index out of bounds exception. Okay? Okay, I'm telling you this is not a good idea. So why? It's not catching number format exception. So don't give me a hard time about that. I'm not doing it because I'm preserving space. Okay? So I'm only catching one of the exceptions, and let's say that's acceptable. I wrote this function. Can you guys see what's wrong with this function? Andrew?
You get an error, it won't return anything.
If you get an error, it won't return anything. It won't even compile. Remember, if you have a function and you go and have if, then, if, and else, if you return a value in the then part but not in the else part, Java complains and says, I want every possible path that this function takes to return a value. And you have taken a path that doesn't return a value. Okay? So I'm this number of input lines function. I did pretty good. I went and gave an argument. And what should I do then? How can I fix this function? How can I make it compile? Andrew?
Return 0 after the check line.
Okay, I could just, so ignoring number format exception, I can have multiple catch blocks for number format. I could just return 0. Okay?
What would happen if you returned like null or something?
Okay, the return value happens to be an int.
Oh, gotcha.
So I return 0. Supposing I could have returned null. Would that be somehow better than returning 0? Andrew? Yeah.
Because the other function, the ECHOLINES, is taking this as an argument, so that would also have to, then that would have to be null over there. I was expecting getting a number of lines, so you're moving an error case to somewhere else to handle it.
Okay. So if I somehow enter null, I'm just passing the buck. And the caller has to go and worry about it, but at least the caller knows something bad happened. But then it has to worry.
I mean, you have the advantage of minus the system recommend this being identical to the user making typing in 0. If you somehow manage to return null, you'd at least have this like a runtime difference between a possible user input.
Okay. So if we could return null, and if null was an illegal value. Null is sometimes a legal value, by the way. I mean, it just means that, okay, I didn't find anything. Remember when we were doing the match title of a course, we returned a null course when we couldn't find anything. That was fine, you know, that was allowed. So at least the program, the person calling knows that there was an error. Okay? So we have a little trade-off to make. The called method can handle the error and make the caller oblivious of whether the error occurred or not. Or the called method can, that's what we've done here. And the called method has just unilaterally made a decision to return 0. If that decision was always going to be correct, no matter who called it, why tell the caller about it? But in general, you can imagine that the called method may not be able to decide without context that how to handle the error. And in this case, the user ran the program, right? The user forgot to enter an argument. Is 0 a good value really for that?
No, because they could have just written 0, I guess.
Yeah, I mean, what did they achieve? Give them at least 1, maybe even 2. But just pick a value, and it seems like 1 would be better than nothing, and who knows what the right value is. But this poor number of input lines doesn't have enough context. It has enough to go and do the job. It doesn't have enough context to go and figure out how to handle it. Sometimes the called method will have, sometimes the called method will not. Because we want to go both ways, we'll complicate our life by making exception handling even more complex. Okay? So, firstly, we have now done error recovery. We just didn't report errors, we are returning a value. Okay? That's interesting. We talked about error recovery earlier. Here we have recovered from the error. Okay? And the caller function may want to assume 1 instead of 0, and the problem is that we have prematurely decided how to recover. Okay? And the caller, in this case, sometimes the caller doesn't have to do it. In this case, maybe the caller should decide what to do. Okay? And now we are stuck with this problem. We can't return null because null is not an int value. Even if I changed int to integer, null may be an acceptable value. So how do I go and tell my caller something bad happened? Is that?
In this case, negative numbers aren't acceptable, so you can just return -1.
So I could return -1 in this case, right? But sometimes, let's talk generally. In general, the range of values I can return may all be legal. In general. You know, in some languages, I forget, in Java, is there something called unsigned? Is there a type called unsigned? In C there is, which says basically unsigned numbers, okay? So you don't even allocate an extra bit for the sign. And in that case, I'm stuck. Okay, or I might be an null, maybe a legal value, or this might be a Boolean value. And what do I do in that case? So what should I do? I want to not just terminate the program. I want my caller to handle this. Yeah.
Make the caller use try catch.
So I make the caller do the try catch. That means and what would I do then?
Say if you return null instead of 0, and you had the caller.
Okay, but I can't return null. I could throw another exception. Okay? So we haven't seen that. So far, exceptions are thrown magically by the system. Now we could perhaps throw exceptions too. That's a great concept. And if I throw an exception here, then my caller has to catch it. Okay? And so we've understood the basic concept. As Fred tried to indicate that I want the caller to have the catch block. If I throw an exception, the caller would have a catch block. Is there something, could I make the caller have a catch block by doing less work than throwing an exception? Because could I somehow have the caller catch the exception and do less work than my throwing an exception? Actually, throwing an exception is the right answer. I'll come to later and say that's the perfect answer in this case. But what do you think would happen if I didn't have this try catch? If I just said return integer.parseInt, and my caller had a catch block. So Java will throw an exception, and if nobody had a catch, it will go and print out the exception. But if my number of input lines does not have a catch, but my main has a catch, what do you think should happen? You're returning the exception to the caller. The thing is that what you're saying here is that this is my legal return value. Please don't confuse my legal return value with my illegal things. Let's go not overload this one little object I can return by having both error and non-error values. This is my legal stuff, and I'm going to essentially return to you the exception. Okay? That's really what it is. That we're going to be returning from methods both legal values and illegal values, and those are going to be exceptions that are returned. And those returned values are accessed by catch blocks. Try catch blocks, okay? Okay, so I want to go and point out that we need to somehow return an exception in the previous case. Okay? How are we going to do that exactly? We'll defer to a couple of slides later. Now let's go and look at this function, method. This method is, and try to understand how it works. So it's got a try, and it's got a catch. And this catch is catching what kind of exception? So this try block is just assuming everything goes well. The user enters exactly the number of lines that's expected and goes and echoes those many lines. Okay? And my catch is going to catch what kind of exception that I talked about a little earlier? The input-output exception, and what is the bad thing that the user can do that will confuse the program? The end of file. Premature end of file. So it's going to get this exception and says, oh, I did not input the number of input lines, and so it just exits the program. Okay, so that's how it's handling this thing. Now suppose, and again, exiting, is that a good idea here? Can you imagine better error recovery? The main method could go and perhaps, main method could do something else. This is throwing up your arms too quickly. So again, we don't want to go and make this guy handle the exception. Okay? And now all your solutions don't seem to work very well. Right? This is not even a function. I can't return a -1. Okay? I could go and make it a function and have only error codes returned, but then I confuse the programmer. The person who doesn't know what errors says, is this a function or is this a procedure? Okay? So this whole thing about overloading the return value to be both legal return values and error values doesn't work very well with functions because there may be no space left in the range of values. It's also confusing. And with procedures, sure, all of these will be error values, but then you confuse it and this no longer looks like even though it's a procedure, it looks like a function.
Can you say the difference between a procedure and a function?
The difference between a procedure and a function, anybody want to answer that question?
Function has an output, whereas a procedure just doesn't ask.
So procedure is, cook this meal. Okay? Function is add 2 and 2. Okay? So procedures don't return values. Procedures are void methods. Okay? And functions are non-void. And so we know as setters are procedures, getters are functions, and if setters started returning values, you'll confuse object editor, and you'll confuse a lot of other readers of the program because they're saying, what does set really return? And they say, oh no, it's the error condition in case something really bad happens. Okay? So the moral here is that we want to return things to the caller, we want to return error values, and we need a way to do that. So decision to halt without full context, maybe echoing fewer lines is okay for this caller, and only a warning can be given. Okay, something else can be done. So let echo lines and number of input lines not do the error handling. All they should do is error detection. Main should handle error reporting and what we do is, how do you pass the buck? We saw many solutions. We could throw an exception. We could try to return some illegal, which is what we're doing here. So we are entering -1, and we said all the problems that this can happen, this can lead to. Does not work if -1 was a legal value. So, and how to pass the buck for procedure? Again, we saw the problem that procedure should not return any value, and we can convert it into a function that returns an error code, but that confuses people. I'm just repeating what I said earlier. Okay, we said it all in one slide. I'm saying it in many slides. Okay. By the way, I spent the weekend and last 2 days figuring out and converting this whole thing into a video that I can just put on YouTube. And rather than you going through PowerPoints and in the recordings mode, and do you guys think that would be good, useful? Would it be? Why would it be useful? It takes a long time, and I would try 4 times before I can do it.
Because if we have Mac cameras today or PowerPoint, so you start making comments.
Sorry, Macs can't play?
Macs can't play PowerPoint audio.
Oh, there is some, oh, I should have told you guys, there is some plugin you can use. Is there any other, yeah.
Well, one reason it would be useful is like, I don't use the audio, so if you just put it up as a YouTube video, like, I would have to go through like second by second rather than
Okay, good.
slide by slide to find this slide.
Okay, good. And also you can do it, unless you use, I think Surface, most mobile computers will not play PowerPoint recordings. They have Office versions, but they don't play it. So this way, I don't know whether you want to ever look at it on a mobile computer or not, but you could, if you just wanted the audio, you could just put on headphones and walk and listen to it also. Okay, so maybe before I prepare for the lecture, rather than my sitting and reading something, I would just take a walk and prepare for the lecture. Okay, so that's my selfish interest in doing it. But anyway, I managed to do it for many of these slides. It takes many tries, and I had to run it all night, and then it says sometimes I couldn't write the file, but I managed to do it for all the threads.
Any given audio on a slide, is there a way to skip to the second of the audio?
Yeah. You can just not be in the PowerPoint mode. I mentioned this somewhere early. You can just be in the non-play mode and click on that icon and just move. Okay, going back to this. We could go and, like I say, convert ECHOLINES into a function and confuse everybody. Perfect. So passing the buck, error codes, and so I'm just, I'm just saying this many different ways. Oh, by the way, what about just having global variables? Just change some global variable that says this error occurred, and let the caller go and look at the global variable.
The method, like going with modularity method, would have to have that pass to it, and then
No passing. Global variable, I mean instance variable. So the method, or maybe some static variable.
I mean,
It just makes you cringe, yeah. Okay, so for every variable, I think I potentially waste a lot of memory. Sometimes is the memory not enough? What if I call factorial, which calls factorial, which calls factorial? How many variables can these factorial functions access? Just one. But I might want to differentiate between the nth call to factorial and the n-1th call to factorial. Okay, so global variables are just often, bad for these kind of things. Okay, and so, and then I have to go and make this variable accessible by all the methods, this global, right? Even though the caller and the callee are the ones that are supposed to look at it, all the other methods in that same scope can also look at it. So I'm telling you, maybe I shouldn't even talk about these bad things, but people have tried this. Okay, so the least privileged and so forth. So okay, finally we get back to what we want to do. We want to propagate exception. We want to somehow return an exception value, and we can do this in many ways. And one way to return an exception to my caller is to just not do anything. I don't have to go and throw a new exception here. I just don't catch it. Okay? If I don't catch having, so that's basically says that you let exceptions be returned instead of regular values. So we saw exceptions are just objects that are typed, and these typed values can be accessed by the caller. So if you don't handle it, your caller can handle it. Okay? So we don't have to have any of these unpleasant alternatives that people had dealt with. I've written programs in other languages that did all the things that I tell you now not to do, because those languages did not have exception handling. Okay? So these exceptions propagate through the call chain until some method responds to them by catching. Okay? So it's like I'm following, and the first floor, am I going to have a net? If not, maybe in the next floor down, I have a net. So the first net that catches me is the one that handles me. Okay? So you can have, this is very important, that you can have multiple nets that can catch the same exception, and the first one that catches it is the one that handles it. Okay? Questions? Yeah.
So are you saying that if you had that last thing where you had a type int method, you could actually return an exception?
Yes, by not doing anything, you are returning an exception. The exception that you should have caught is the one you return, and that you don't catch is the one you return.
But you can define more.
Yeah, so you can have 10 different kinds of exceptions, and any one of those can be returned back. You can only return one legal value, but you can return many different kinds of illegal values. And these illegal values are exceptions. Okay? Questions? So, caller, now here's an issue. You decided as a called method you were not going to catch this exception. Okay? But wouldn't it be nice for the caller to know whether you caught it or not? Right? If you're going to not have your net on this floor, it'd be nice to tell the guy below you, you should have a net. So, how should I tell? When I am the writer of ECHOLINES, how should I tell my caller, I'm not going to handle this exception? I'm not going to have a catch. Because there are two cases. I could handle it or I could not handle it. If I do handle it, I have to tell the ECHOLINES, my caller, nothing. The ECHOLINES caller can just be oblivious to the fact that there can be an error because it knows ECHOLINES will handle it. But if ECHOLINES is not handling it, I should go and tell my caller what's happening, right? Because after all, look at this void. By having void here, I told my caller, don't expect a value. By putting int here, I tell my caller, expect a value. Won't it be nice to even somehow go and tell the caller, expect an exception? And if you were to go and so how could you go and tell it? I mean, what do we really want the method header to do now? It should go and list the exception, right? You should go and say, this exception I expect my caller to handle. This exception I expect my caller to handle. And the way to do that is by saying throws exception, as somebody said. So this is what we do. We tell the caller that passing it or throwing the exception a special return value. So this is just like my void. I return nothing as a legal value, but I might give you this present, and this is my exception. Okay? So a little bit more syntax. Try, catch, and throws. Okay? Questions? I see people looking at this slide very intently. Okay, so all you're doing is acknowledging in your header the type of return value, essentially. Think of exceptions as return values, and you're just saying, this is my return value, one of my possible return values.
So you have to list all of them so you can return?
Have to, should. Okay? So let's say you can. Okay, we might need a lot of next time's lecture to indicate the difference between can and should and have to. Okay? Let's just say right now that you should or you can. Okay? So I'm saying that. Any question before yeah.
So this isn't a separate method from the method that tries and catches.
Okay. ECHOLINES is a method that has been called. It decided it was not going to have a try catch here.
Okay.
It wants its caller or its caller's caller to handle it. So it goes and tells its caller, I'm not handling IO exception. That's all it's saying. The caller can decide to have a catch or say, I'm not handling it either. And say, I'm returning it to my caller. So this is a way for the caller to tell the callee, to tell the caller that I will return this value to you. That's the way to say it. And you should have the catch. Now I can have a catch for number format exception here and not a catch for IO exception, in which case I will go and say, I'm giving you the IO exception, but I don't say anything about number format exception. Okay? So all the exceptions you're not catching are the ones you return, or you can return. Okay? So in this case, my echo lines doesn't have any try catch, but it has a throws. Okay? So the programmer was pretty lazy, didn't have any try catch, but the programmer has to do some extra work by saying, I'm throwing this exception. I'm not really throwing the exception, I'm passing the buck. Okay? I didn't really do a new exception and throw it, which is something you can do. I just, whatever exception I got, I threw it back. Yeah.
But if you had a method that could conceivably throw what the one happens.
Then you would say, throws exception 1, comma exception 2, comma exception 3. And you can have catch exception 1. Yeah.
Sorry.
No, that's fine. Even in the catch, I can have catch exception 1. You can have a try block that goes and possibly throws 5 different kind of exceptions, and you can say catch exception E1, exception E2, exception E3.
But not like a generic type.
Okay, so yeah, we could go and catch something more abstract than each of the specific exceptions. Let me just get Peter's question first.
So even though this is a void method, it can still return.
An error. It's not really returning. It's just not catching, and you can think of it as returning. And that's what we were trying to do with the procedure codes, right? We were saying, yes, if the procedure works fine, we don't return anything to the caller. But if it does not work fine, we want to return error codes. So yes, it's a procedure, and in the error case, it's returning an error indication. It's not some value that is used. Zach?
If you're going to catch multiple exceptions, like exception 1, exception 2, what's the syntax between them?
Yeah, I'll show you later the code. Okay.
So is this putting print line the input, is this kind of like understood try catch thing? So if that creates an error, what would it ultimately print?
We don't know. The caller of echo lines main will decide that, and we'll get to that. Okay?
Is the throws exception part of the method header not appear in the interface?
So if this, yeah, good. I mean, if this was an instance method, and this was defined in a class, the interface can and should, in this case, also have the same thing. We're going to be answering, hopefully. And this is what's happening, okay? My main is now has a try, echo lines, and catches array index out of bounds exception here, and catches IO exception here. Both of my methods are now just passing the buck, and the catch is being processed here. Okay, and you get to see how we have multiple catches also. You have a catch followed by another catch, and this is the one that catches the array index out of bounds exception. This is the one that catches the IO exception. Okay? And the main method knows to catch the exception because the called method went and acknowledged it. Okay? So we have about 30 seconds left. This code actually will not work. Okay? So we'll see why it doesn't work. And look at this line here. And what are we doing here, by the way? Let's just quickly. What am I doing? I'm error recovering. When the person doesn't ask to enter any argument, I do echo lines 1, which means I will go and echo at least one line. Okay? And this is going to cause us some problem, and we'll see that next time. Okay, so what we'll do is I'll cover as much of exceptions as I can, and then 5 minutes before class ends, we'll briefly talk about the exam and what the exam's going to cover. Okay? Any questions? So we were looking at exceptions last time, and we saw that we could execute statements like read line that have the potential of causing exceptions. In the case of read line, you could reach the end of file and so not have a line to read, and other kinds of errors could also occur, especially if you're reading from the disk, a file. And when you have an operation that can cause an error, you have two alternatives. You can try to surround it with a try-catch block and handle the error or handle the error there, which might involve just reporting or recovering. And that's a valid strategy. And that's relatively easy to explain. And another valid strategy is to say that, look, I don't have enough context in me, I'm the caller, to handle the error. Okay, so I'm going to pass the buck to my caller. Okay, so just as I, as a function, might return a legal value to my caller, I can return or basically not catch an exception, which means it just implicitly returns to the caller. Okay, and if I do that, it'll be nice to tell my caller that I'm going to do that. So just as I go and tell my caller whether I'm going to return a value or not, and if I return a value, what type it is, I could go and tell my caller what kind of exception I might give to it, pass to it. Okay? So that's what this throws clause was about. It was like an extra return value. And where in languages without exceptions, you would have special error codes, and you'd have a single value being used both for error codes and for legal values. Now you have two different objects, or multiple objects. You have one object that's being returned, or in case of procedures, nothing is being returned. And you have various kinds of objects that can be returned for exceptions. Okay? So that's what we saw last time. And we saw that in ECHOLINES, we just decided, in this particular case, that we really wanted main to handle that exception. So this is that main called number of input lines. This method also executed an operation that can cause an exception. And again, we decided that this particular function should not go and handle it, and it should not go and return some negative number, because that will just confuse somebody who doesn't care about errors. And so this way, the legal value is returned here, and the illegal object is thrown back to the caller. Okay? So in both cases, we were deferring to the caller. And I'm not saying that's the right thing to do, because when you defer to the caller, then every caller must go and handle the exception. Okay? So if you can handle it within that function, please do. But often you don't have context. Okay? And when you're not handling, somebody else needs to handle it, and in this case, it's the main method that's handling it. And we see that this main method also has a try-catch. This try-catch has echo lines, a number of input lines in it, and if you look at the code if you look at this code without knowing what happens in the call functions, you don't see any real error operation occurring. But in fact, the call methods do have errors, and they are advertising that fact. And so main knows that it has to handle these exceptions. And our previous try blocks had only one catch. This try block has multiple catches, one for each kind of exception. Okay, so exceptions are typed, and we saw that you can have a legal return value of some type, plus you can have these illegal values returned to you of different types, and for each type, you have a separate catch block. Okay, so we are seeing here an example of how to have multiple catch blocks with tries. Okay, and what are these catch blocks doing? They are reporting the errors. Okay, and this catch block is trying to not only report the error, but recover from the error. It says, oh, the user did not enter any argument. Let's assume that rather than having the user enter the program, run the program one more time, let's give them a chance to enter at least one line. Okay, so this program, if you remember, it took from the argument the number of lines it should echo, and then it went and read that many lines and echoed those many lines. And if the user did not enter an argument, then it assumes that the user wants at least one line echoed. So it goes and says, it calls echo lines with 1. Otherwise, it just calls echo lines with the number of lines the user input. Okay, so it's doing some error recovery. And that's a nice, ambitious thing to do. It's a very difficult thing to do, but it's a nice goal to have. Okay? This is where we left last time. Okay, and I told you guys last time, look, this program won't really work. It won't even compile, actually. And can anybody see the problem?
This might not be right, but if your drawn number of input lines are, so that returns an error, then it's going to try to print something because we're trying to find how the main thread goes, so we try to want to echo lines on the one, but it seems like without that echo line to one, and maybe you can make that echo line to one, you want to try to print something in the middle of your trying to execute the echo lines right there.
Okay, go slowly. All right. So you're saying there's some problem with this part?
Yeah.
So you're happy with this catch block? Is this okay?
I mean, I feel like either one of these would run, or none of these would run, but catches.
Okay, so here's the deal. You can get only one exception at a time. Okay? You can't get 2 exceptions because you were executing some statement in the called method, and that didn't succeed for one reason. And at that point, the try block is terminated. You don't go and try to execute the other statements within that try block. Okay, so that's why you can get only one exception. The moment an exception arises, the try block is terminated. That's why you put these quotes here, saying, this is my scope. And if the very first exception should go and exit it. Okay, so it's going to execute one or the other, and this is really an if-else. What's it saying? If my exception is instance of array index out of bounds exception, do this block, else do this block. Okay, so just as you have only one if-else part, execute, either the if or the else part, the then or the else part. Okay.
Does the echo lines not have an argument, even though you said that there was one?
Echo lines does take an argument, right? It so happens a number of input lines went in and read args that was passed to it. Okay, so args was the argument that the user provided. Nothing. So it passed it to a number of input lines. Number of input lines tried to index it, and it threw up its hands and passed an exception back to this guy. It says, okay, I understand that there was an array index or a bound exception. I really know what that means. So I will just call echo lines with 1 rather than just not do anything at all.
So it would run forever, but it's expecting the user to input something.
Okay, so there are 2 forms of input. One is in the main argument. One is the console input. Main argument didn't happen. It says, okay, I will go and give the user a chance to enter one line from the console. In the normal case, the user says 4 in the main arg, and it gives it a chance to echo 4 lines. When there's nothing, what should it do? You could say echo no lines, but we are trying to be a little clever and say 1. Okay? Let's not debate too much whether that's right or not. I don't know it's right or not. Andrew?
You're not catching IO exception from the second echo lines.
Okay, so the problem that's occurring is we're trying to do too much. And whenever you try to do more, the more you do, the more errors you make, right? That's fact of life. So I'm doing error recovery. When I tried this echo lines, I can get an IO exception. That's what I've got that handled here. Now I'm calling echo lines with 1, and this echo lines can also throw an IO exception. And there is no IO catch block for this guy. There's no try block here. This try block is handling this echo lines. This catch block is handling, the same echo lines. Whereas there is no catch for this exception. Echo lines can throw an exception and what happens to that exception. So basically, we are trying to do error handling, The error handling code can itself throw an exception, and we're not catching that exception.
What you're saying is Java won't let you call method without checking try catch block if it's going to check it.
Yeah, so Java says that you better go and catch this exception. At least in this case, it's saying that. Sometimes it says it's okay. We'll try to figure out how it decides that. But here, Java says you really should catch this exception. So if Java really insists on this rule, how should I change this code? Austin?
Can you put a try catch block, like try one catch IO exception?
So I nest the try catch inside this, just as I can have nested ifs. Same thing, right? Because I would get an exception and I would go and say if it's this kind of exception, that kind of exception. KJ?
Put a while block around it, so instead of calling the echo lines after it failed, you just have a while loop, so it's before the try,
So my while loop, I don't have, it's, while loop means I'm going to do a bunch of things. So what you're saying is that I call echo lines once, I call echo lines a second time, so somehow there's a while loop, it should be done with a while loop, while I can't echo, keep doing it. Right? That's a little bit more.
Is there a reason you shouldn't just put the try catch blocks in the echo lines method?
Is there a reason why we couldn't put the try catch block in the echo lines method itself? And that's what I was saying. There's two ways to go about doing it. If we put it in echo lines, it doesn't know the context. So should it choose 1 or should it choose 0? It doesn't know. And we know that this main method knows that the number that it passed to echo lines comes from argument is a number of lines to be echoed, and it came from the arguments, and the argument was missing. So it has more context to put 1, whereas echo lines doesn't have enough context. And that's, like I said, you can go both ways. And if I go that way, life is easy. I want to make life complex. And I want to talk about a situation where the method cannot solve the problem.
Wait, so are you asking, like, what should we do with the echo lines from season 1?
Yes, and we already got the answer. Okay? So the reason I'm not doing it in echo lines there is because I want context. Okay? And IO exception is not caught. And I can do some while programming that really doesn't make sense here, actually, because we don't want to do it repeatedly. We're just doing it twice. Okay? I do something like this. Okay? I say try echo lines 1, and I catch this exception, and I'm giving a message here, did not input the 1 input string, which is the default in the case of missing argument before input was closed. So I'm being very clear. This is what I tried to do. You did not even, so the user did 2 mistakes. Okay, the first, the user did not enter an main argument, and then when you were provided with, one line to echo, the user just said, end of file, and terminated. Okay, so it's saying, okay, this is why I try to do it, and this is the reason why I'm failing. So, this is really what you want. You don't want some awkward while loop here, because you're not really doing it a third time. Okay, you're just doing it twice. There is nothing to count. Okay, everybody happy with this? So you can have nested try catches. That's the point I'm going to make. Okay? Okay. Notice here that I used E here and IOE here. Okay, E is like my eye. I mean, it's kind of got a well-defined name. I like to use long names. But for indices, it's universally accepted that I is a good variable. And similarly, it's universally accepted that E is a good variable for exceptions. Okay? But I couldn't use E I couldn't use E here. So why could I use E? Yeah, Fred?
Could you create basically like a try echo lines method that contains try and catch blocks and uses recursion? So you don't have to nest try and catches.
So you want me to also handle in echo lines the exception? Is that what you want me to do?
Well,
My question right now is, okay, first, are you trying to answer my question or you have a separate question?
separate question.
Let's try to answer my question first. Okay. Yeah.
So like the catch statement is just another block of code, and in that block of code, it knows that the E is an array index outbound exception. So you cannot reuse the variable E, whereas when the code dies and E is no longer associated with anything, that's why you can use it in this last catch statement.
Okay. So this catch and this catch have both got curly braces in them, right? Curly braces in general define scopes. Okay? Scopes are areas of code that have variables that you can declare in them. Okay? So this scope and this scope are independent. It's like two methods two instance methods in a class that can both have the variable e because they're independent scopes. Okay? You're going to be either in this or this. But when you are here, this scope is nested within this scope. Okay? And just as a method is nested within a class, so the instance variables are visible in the method, this scope's variables are visible here. So Java could have used two rules. It could have said, if you declare an E here, then this particular E is hidden. It could have done that. Okay? Just as when you declare a variable I in a method, an I instance variable gets hidden. Or it says, no, I won't let you hide that variable, and so I'm going to go and insist that the nested scope have different name not use the variables in the scope it's nested in. Okay, that's the reason for IO. Okay, back to your question, Fred. So what's your question?
So, if I remember correctly, can a method throw multiple possible exceptions?
Yes, a method can throw. Yes, in fact, we'll see on the next slide that if this main method did not catch these two exceptions, it could have thrown exceptions to its caller, and it could have thrown both exceptions. Okay.
So, my question is, say if we went back a step and we went to the old code, and we didn't have a try and catch calling to the echo lines called once parameter. Can we create a method called try echo lines, which was identical to that code before, except it used recursion. So to solve the fact that this solving call of echo lines 1 doesn't have a try and catch.
Okay, so you're pretty much saying what KJ said. He said, let's have a while loop, you won't have recursion. And while loops and recursion are duals of each other. Right? I just want to do two steps. Either I want to do one or nothing. So why do I need recursion? I can have a try-catch block, and yes, maybe in this case I just want to, but yes, you can try to do more than one. If the person doesn't even enter one, they can try another value, so you can keep going. But each time you're doing something different, and that recursive method is going to become very awkward, just as this while loop is going to become very awkward. Okay? And I didn't want to debate too much the right answer. I just want to show you nested exceptions and nested scopes here. And I can do it with this example. Okay, so that's the real reason I'm doing it this way.
You wouldn't need recursion in Fred's example, because you could just call try echo lines 1 and then you wouldn't need one nested loops.
So not recursion, but just have a separate method. Just not have this long method here. Look how complicated this code has become. Okay, I want to point out this thing. That my normal code is one line. My error handling code, and when Word crashes on you, when Google Docs crashes on you, guys, error handling is hard. And this slide is showing you that. Okay, and that's why it's good to separate the erroneous code from the non-erroneous code. And my erroneous code has become very clumsy. Okay, and how do I go and modularize it? Exactly as you guys are saying. Okay, that I certainly have to have the catches in the scope. I can't avoid that. I could put this in a separate method, but it's going to just do this one line. But it will be nice to go and put this whole code in another method so that this particular main method becomes less cluttered. Absolutely. Okay, not recursive, but I'm just going and taking something that's a monolithic method and making that into multiple methods. Okay.
So in the nested try-catch, the system would print out did not input the one input string and so on. If the user failed to input that one line in the console that was required by the echo line.
Absolutely. That's my message. So I couldn't go and this message are different. Okay? Sorry, this message and this message are different. That's why I didn't modularize it. Okay? But absolutely, to avoid this nesting problem, we could have just had a separate method and then called it E. But in that method, then this particular E wouldn't be accessible, and you'd have to pass it as a parameter if it's really accessible. So, yeah, that's not the point I'm trying to make, but indeed, you should not have such big methods, okay? Other things? Okay, so let's go to what, parameters and symbols. And here, my main, we show that we can have more than one exception being thrown. And my IO exception and array index out of bounds exception are both being thrown by main, because main doesn't handle either of those two exceptions. It says, I'll pass it to my caller. Okay, so everybody's now got into this pass the buck. Okay? Who is main's caller? Who calls main? Operating system, Andrew? The interpreter. Okay? So the JVM calls it. Operating system calls JVM. You say Java, and Java calls me. Okay? And we've seen when we don't do any handling, it is main that goes and prints the stack trace, and it tells you what the exception is. Okay? So this is equivalent to doing nothing and saying, I just want the default handling, which isn't that bad, we saw, compared to some other languages. Okay? So this is probably not a good idea. Okay? But I want to show you that multiple exceptions can be thrown. And if you throw it, if you don't catch an exception, the interpreter or the JVM finally goes in, catches it, and has to handle it. And it has a default way of handling it. Okay? Questions? So this is really not a good idea. Okay? I'm just demonstrating these concepts because you can probably do better than the interpreter does. And the interpreter is just going to say, as we saw last time, array index out of bounds exception. It's not going to say, hey, user, you forgot to enter an argument. Okay, so we really should go give those long messages that we saw in the previous slide. Okay, but you can do this. Okay, so we were bad that we went and through the exceptions to the interpreter, but at least we. So let's look at some of the alternatives we have for array index for number of input lines. I can go and cache the exception, and that is not a bad idea. Again, I went to this more complicated case. In general, it's not a bad idea. In this particular case, I argued that the 0 was not a good value to return back. Or I can I can not handle the exception and acknowledge the fact that I don't handle the exception, and by this throws clause. This goes to your question now. What if I go and not handle the exception and not have a throws clause? What would that mean? And would that even be legal? Right?
It's definitely legal because I think we've all done that before.
You've all done that before. You've all handled array indexes, indices, and not done it. Excellent.
Isn't it, like, would it just still throw the exception up and so you can catch it later? It's just not informing future users of it?
Okay. So it's not as if this particular throws clause has any effect on the execution of the program. It's not as if some value will be returned that won't be returned otherwise. This throws clause is purely a form of documentation. Okay? So the exception will be propagated regardless of whether you go and say throws or not. And like Zach said, we've all done it before. Okay? Now, so given that Java can let us do this or this, which should we do really? Now that we know better? You've all done it before because you didn't know better. Now that you have this extra tool in your hand, should you use it everywhere? Should I have actually said this here? Should you document? Can't argue against that, right? Especially when we guys are not catching you on comments. Okay, at least do this kind of documentation. Okay, and this is a good kind of documentation. Documentation that the Java understands, can interpret, something we can check through our grading program without interpreting and scanning comments. So this is a good idea to go and tell the caller, look, you handle it, I'm not handling it. Okay. So throws is a form of documentation, just like comments, but comments are unstructured. It's more like annotations, your interfaces and assertions, which are something that the programming language can understand. Okay?
So if you throw index out of
Okay, so that's a good question. So this particular function, we saw that we got away here without saying throws. For the same reason, if we say throws here and main doesn't do a try catch around it, it'll be fine. You shouldn't, but it'll be fine. Okay? But we'll answer the question really properly in a few minutes. But the answer right now is that just as you can get away without a throws here, you can get away with a try catch in the main also. Okay? In this case. Okay? So guys, at least understand what's happening here, that we really should have said throws. But if we don't, Java won't complain, but our grader program can catch these things and say, hey, you did not throw this exception, and here's 5 points taken out. Yeah?
So ultimately, does the operator or the interpreter set a general exception class equal to the main, like the main class that runs the program? So it's always passed into it, and then it sets that error and runs it as like an error parser or something like that?
Exceptions are all typed. Okay? So if somebody throws an exception, array index out of bounds exception, it'll remain an array index out of bounds exception till it reaches the interpreter. It's not going to get collapsed into some general class, the interpreter, because the interpreter is going to go and actually tell you what kind of exception it was. So it needs to know the exact exception. So I think you said that does it go and convert all exceptions into some general class of exception?
You know how we always say like interface name is equal to new thing or whatever. So it would say error, whatever the error name is equal to main, and it runs that, and then would all return back to it, and then it could be like a whole separate program to run the error that was set, and like figure out what
Okay, so the main method, the interpreter, when it gets an exception, has to go and give you some message, right? It's not going to try to recover. It's not going to run any code. It's just going to report the error. It needs to know exactly what the error is.
based on the type that was returned to it, it would know.
Yes, but there is some general exception class that has some general method that the interpreter can call to figure out what message to print. And we'll see that also in a few minutes. Okay? Okay. Now I'm going to confuse you guys. Okay, so if we don't document, again, I'm trying to convince you guys that this at least in this case, just in this case, saying throws array index out of bounds exception is a good idea, because this way the caller knows that it must handle it. Okay? So this is good documentation for the caller. And otherwise it may not have code to handle it. But Java is not going to complain, so our grading. Okay. And now my main method can go and say throws array index out of bounds exception. And I guess what I'm trying to say here is, if I go and look at echo lines, and in echo lines, if I don't catch the exception, and I say I do not acknowledge the exception, Java will do what my grading program was going to do. It will complain and say, sorry, you must say throws. So in the previous case, it said, that's okay, let the grading program check this. But in this example, if echo lines neither catches nor acknowledges, which is what's happening here, that this is not acknowledging, and the main method doesn't catch this exception either, and it doesn't acknowledge either, and Java will go and not complain in both cases. Okay? So Java is not uniform about what it does. Okay? That for some exceptions, it checks that you are actually acknowledging an uncaught exception. And for some exceptions, it does not do the checking. Okay?
So is that because it's an IO exception that it requires you to either acknowledge or
So somehow it makes this rule, and between these two programs, and it really can't analyze your programs, because of the halting problem. So it's going to use some very crude method of doing so, And the crude method is that some exceptions are checked exceptions, some are not checked exceptions. IO exception must be a checked exception because we see it's being complained about here. And array index out of bounds must be an unchecked exception. Okay, so we have to complicate now our whole explanation of exceptions by saying that there's two kinds of exceptions. Not all exceptions are equal. Okay? And that's what I'm trying to say here, that we have to now think about unchecked exceptions and checked exceptions. Okay? And checked exceptions, you have to worry about interfaces also. Okay? So if my echo lines here, in my previous example, echo lines was a static method. Okay, so I didn't have to worry about interfaces. Let's suppose that echo lines becomes now an interface method, an instance method, which means it can be put into an interface. For checked exceptions, if my instance method does not catch the exception, then we see that it must, in its header, say it throws IO exception. Do you think the interface header should also have this rule? Should. It's documentation, right? And ultimately, the user of that class is going to look at the interface. They're not going to look at the class. Okay? So, if it's not caught in body, it must be act in method header of the class. And if it's act in method header of the class, it must be act in, sorry, this should have been interface. It should have been act in the interface header of the method also. Okay? So that's our checked rules. Zach?
If it's act in the interface, what's the method header, does Java require it to be in the class method header that implements the interface too?
So if the other way around, if it's act here and not act here, will Java complain or not? Okay? We might not get to that answer today or ever, depending on what we do in the last day. It's complicated. Let's just say that this particular method, whether it's act here or not, depends on the body of the method. Okay? So the answer is no. Okay? If it's act here and it's not act here, it's okay with Java as long as the body is consistent with the header. Why that's the case, you'll have to wait for that. Okay? Andrew?
So the purpose of using interfaces is so you can change your code in place of new implementation without having to change everything. So what if you change something that doesn't throw the exception? Will Java be annoyed because you have this throws here, but you're not actually throwing it anymore inside from your package?
Okay. So you guys really want the answer from me right now. This is really Zach's question. And you're trying to ask, why is that the case? And let me just sort of give you an analogy here. So if I come into this class and I say, I really don't know exceptions, I really don't know loops, but I'll try to explain them to you, right? And I try to explain, so I go and act something that is, I'm underestimating, I'm underselling myself, okay? If I undersell myself and I do a good job teaching exceptions, you'll be all delighted, right? But if I come in and say, I know everything about exceptions, and I can't answer this question for you, you'll say, I don't trust this guy, right? If I give you aspirin and say, no side effects, and you get bleeding, you're going to be really mad, okay? Rather than vice versa. So what went wrong? If in the interface I go and say, I really don't handle anything. You handle IO exception. You handle this exception. What's going to happen? Your main method is going to be ready for these exceptions. It's going to be ready to get dizzy. It's going to be ready to look up Google for exceptions rather than rely on this, right? So it's okay to undersell yourself in life, I think, and in Java, okay? So the real reason why you can get away with and I really wanted to explain this stuff to you guys, but, I didn't know whether I'll have time to do it or not. So I'm kind of glad you forced me to say this. I've got slides later to say this in a better way. So you can, and Andrew was kind of giving the reason, that this interface method could be implemented by 5 different classes. 4 of them could be well-behaved. 1 could be one that doesn't catch the exception. So it's okay for the interface method to be more conservative, and for each class method to go and say, look, I don't throw an exception. I can guarantee you that, so I'm not going to acknowledge it. Okay? As long as the interface acknowledges it, Interface will acknowledge it as long as there's even one implementation that may have it. So that's the reason why, even if one person gets dizzy with the medicine, you go and say it can cause dizziness. Okay? So that's kind of the analogy, and I'm doing this without slides. I have nicer slides to say this nicely later, but that's the intuition. Okay? Questions? Okay. Now we have to figure out, we understand the rules, kind of. Okay? There's checked exceptions, there's unchecked exceptions, but why? Why have rules? The more rules you have, the more time I have to spend in class explaining them, the more you have to study, the more questions I can ask you in the exam. So, why not just have one uniform set of, why have this situation where array index out of bounds exceptions need not be acknowledged, but IO exception must be acknowledged, and you get an error in this case, and you don't get an error in this case. Why? KJ?
There's IO exceptions are out of control, whereas if you have to write throws, array out of bounds exception, which is really annoying.
If you had to say throws, array index out of bounds, array index out of bounds exception each time, there'll be a revolt here, right? I mean, you don't get to write code. You get to write mostly throws clauses. Whereas IO exceptions you think are out of your control. Whereas array index out of bound exceptions you think are in your control. Okay? That's Java's principle. Okay? And it has to do with the kind of errors. So the errors that are under your control and here's where you'll have a revolt. Okay? Here I am, I'm saying args is hello and goodbye. And then I go and say print line args1. Is an array index out of bounds exception going to occur in this case? Ever? It's in your control. I was able to control it. I programmed well. And why should Java go and force me to go and say this? Now, here's what Java could do. Java could go and say, I will analyze your code and see whether args1 could ever be a subscript error or not. I will just understand your code and force you to go and say this only if you have made an error. Could Java do that? Because of the halting problem. If it can't even tell you whether your program will halt, how can it tell you whether it will go and have this particular state at this particular point? So because of the halting problem, it can't in general tell whether some code will actually cause exception or not. Now in this case it can. The tools are good enough to know that since there's no loops here, it can easily go and tell that this will not be executed. Okay? But in general, it doesn't want to bother, and it's going to take a very conservative approach. Okay? And when it takes a conservative approach, it wants to prevent as much as possible the cry-wolf syndrome, where you're just giving false positives needlessly. Okay? And this will be a cry-wolf situation, because it just says, the only rule it can use, that the naive rule is that if a subscript error can be thrown, that means if a subscripting happens, I will go and ask you to acknowledge, and subscripting can happen without it being unsafe. Okay, array subscripting can happen. So it's guaranteed to not happen, and array indexing does not imply exceptions. There's a lot of text I'm going to go through right now because it's important. So it implies it may happen. Halting problem prevents Java from knowing if an exception will actually be thrown. In this case, it can check that, but it doesn't. And its exception checking assumes the worst case. Okay? And in the case of checked exceptions, maybe the cry-wolf won't be too bad. Okay? That's the hope. That these kind of exceptions, the false positives will not be too many or at all. Okay? And if you make all exceptions checked, then we would have much more cry-wolf than otherwise. Okay? So now the question is, what principle do we use to decide which are checked exceptions, which are not checked exceptions? Okay? And gave us the reason that there are exceptions that are under our control, and there are ones that are not. Internal errors are errors in our program. External errors are errors because of the user, because of some other program, because of the disk, who knows what. So exceptions that have to do with user and external errors are checked. Exceptions that may have to do with them are checked, and the exceptions that probably have to do with internal errors are unchecked. Okay, that's its principle. Okay? So we know that there exist two kinds of exceptions. We know the principle behind that. Whether the principle is actually followed or not is the next question. Okay? Questions? Okay. So the question is, which kind of error? And again, this is just stating in text what I said earlier, that if it's an internal error that you have prevented, then hacking is bad for two reasons. A, you have to go and type all that junk, and second, it's misleading. It's not even true. Okay, so you really don't want the false positives. Okay, so that's what this text is saying. Java rules are justified if checked exceptions are external errors and unchecked exceptions are internal errors. If that is the case, then Java's rules are the perfect rules to have. Okay. Now the question is it true that based on the two examples you've seen, that checked exceptions are always external errors and unchecked exceptions are always internal errors? Based on the examples we've seen, no, right? Because this is a user error. The user did not go and enter an argument. It manifested itself as an array index out of bounds exception. Java decided when it was classifying exception that would be an unchecked exception, but it's not in this case. So Java's rules are not quite working right. Okay. So given that this is really an user error, how should we go and circumvent that problem? And given that Java has just made a mistake here, and Java's made a mistake because it can only say probably. Probably this is because of internal error, but probably this is because of external error. It doesn't really know. We still want to have good documentation, and we want to be able to have checking to prevent us from doing wrong things. We want to do the right thing. We want to acknowledge in this case. Java is not forcing us to do it. How can we go and have a discipline that goes and forces this method and its caller and other callers to acknowledge this exception? So what could we do here? So what we could do is what I said earlier. Go and say throws array index out of bounds exception. I could just be good here. But then KJ will ask me, what about its caller? What if the caller doesn't go and put it, and the caller doesn't handle the exception? What about its caller? And the caller maybe doesn't know very much about this particular exception. So how could this guy who wrote number of input lines is very disciplined. We trust this person. This person wants to document, and they want it to propagate up also. So by saying throws array index out of bounds exception, I've solved the problem at one level, but not at another level, or when it comes to my being called. Could you create a new exception class? That's exactly what I'm leading to. Okay? And that exception class could be a checked exception. Okay? And then what would you do? You would go and, what would this particular method do then with that exception class? So it would catch the array index out of bounds exception and throw the new exception. And that would be a check exception, and that would force the caller also to go and either catch it or acknowledge it in the head. That's exactly what I'm leading to. And before I go down to that step, I'm going to take a lazy approach. So what I'm saying here is that there is no reason, no way to force every caller that does not handle it. And what I could do is take a lazier approach and say, I will convert my array index out of bounds exception into an IO exception. After all, an IO exception is an input-output exception. It's a very general class. And I will go and say, throw new IO exception and say first argument missing. Now we know IO exception is checked, so now my caller will have to go and hack it. So you want KJ's scheme or you want this scheme? New exception or just use an existing exception? Andrew?
So new exception because with the current code, when you get the IO exception, there's already code there for handling it, so it wouldn't really ignore the fact that the arguments.
Yeah, so maybe I'm making it too general. And I'm missing the fact that this is a missing argument exception to be handled differently. And what am I doing? I am being a little good. I'm giving this error message here. The code there could go and look at, there is a way to get the message that you are putting in here from the exception object that's passed to you. It could go and get that message object, decode it, and figure out that this is this kind of exception. But why should you go and parse that code? Okay? So why not just have a new type of exception that indicates it's this kind of exception and have a separate catch block for it? Okay? So we're going to do, so we can throw exceptions. That's nice, by the way, that we can throw our own exceptions. It's not that we only propagate exceptions thrown to us. We can actually throw our own exceptions. Okay? And here's the message. And now we do force every caller that does not handle it to ACK it, but we've lost the fact that this is this kind of IO exception. So exception message distinguishes it from read exception, but we don't want to decode it. And we'll go and throw a missing argument exception. That's our type, and we can also give a little message to be printed out for the user. Okay? So that's so that we can have our own exception classes. This is power. Okay? Not only can we throw exceptions ourselves, we can have our own classes also, and you've seen that in recitation also. Well, I'm just curious, how many of you did assignment 11 with exceptions? Okay, excellent. Okay. One person kind of did it, but that was, you had to go and understand all of this stuff, and it's not easy. And except error handling is not easy anyway, and to use exceptions for it is very good. Okay, excellent. I was wondering whether I should even put that in or not. I said probably nobody would try it, but I'm glad I put the challenge in. And how many of you did undo? Okay, 3 people. So maybe I will explain a little bit of undo on the last day of class so that you understand what you were doing. Okay. Now the question becomes, how do I declare missing argument exception? And what do you think goes? Oh, you guys have seen this in recitation. So let's just go and so type of exception rather than message. And here's our missing argument exception. Okay. It extends IO exception. We know it is the form of IO exception. And what does it do? It just passes the message to its superclass, which knows how to store the message. Every exception has a message stored in it. We see from this. And it just takes its constructor argument, passes it to the superclass. So it's doing nothing beyond passing the argument to its superclass. And we know it's a checked exception because IO exception is a checked exception. It's a subclass of IO exception, so it must also be a checked exception. Okay? Any questions here?
In the last slide, what is query?
Query? To go and, so if I'm not giving you information, you have to query me, right? You just queried me with this question. You pulled it out from me. So you have to go to the exception object and get the message out from it. So if you study databases ever, you sort of get from the database information. Okay? Okay. You just forget sometimes how much of a nerd you are when you spend so many years in computer science. That which are English words and which are computer science words. And they keep asking you guys, is this word in English also? Okay, because I've forgotten. I'm brainwashed. And it's interesting now that computing is so pervasive that you can use words like caches and the general population will know what you're talking about, because when they go and buy their computers, they are told, this has got more cache than this computer. And at one time, you just were weird. Okay.
I think this is a bad question, but if we were to use these in classes and it says throws an error, would it say throw a missing argument exception? Or we can type it as an IO exception that doesn't really work that way. I guess we'd say throws a missing argument exception.
You would always throw an object. That object should be of type exception. And what we did in the previous slide was say throw new missing argument exception. We could have constructed the object first, and then thrown it. You can construct the object and not even throw it. Actually, I do that in programs I've written. Okay? Because exceptions have this stack inbuilt into them, and I want to know the stack sometimes. So you can, and we just did it all in one statement. Okay? Questions? Okay, so we know this missing argument exception must be a checked exception because it's a subclass of IO exception. Supposing I wanted to create an exception that is not checked. I just want to type the array index out of bounds exception as saying you did not index the first element correct, and I wanted a separate exception for the second one and the third one. Okay? How could I make an unchecked exception, you think, in Java? Zach?
Could you just extend an unchecked exception?
So you would have to extend some existing unchecked exception. So it would be nice to have some general class, which is an unchecked exception and subclass from there, right? And does anybody know in Java what is that class? Andrew?
Runtime exception?
It's a great name. So, okay, by the way, there is no interface here, and I'm not being bad. I'm not adding any methods, and Java does not have interfaces for exceptions. So I can't have, I don't want to go and take their methods and put them in an interface. So we just don't have any interfaces here. Okay? Java, I keep saying that Java should have had interfaces in many places, and it doesn't. And this is one example. Okay? So I'm just justifying why a missing argument error is a subclass of IO exception here. And is this checked? And we know IO exception is checked. I have some general rules. An exception class must be a subclass of an existing exception class. Okay, that's what makes it an exception. That's what makes it have some message that can be printed out by the interpreter, have a stack trace that can be printed out by the interpreter. And any class that is a subclass directly or indirectly of runtime exception is an unchecked exception. Okay? And any other, if you don't have in your, as a superclass runtime exception, you're checked. Okay? And I said it's a great name, runtime exception, and I was being a little sarcastic there. Yeah, Zach?
Is there a general class like runtime exception for checked exceptions?
No, so we just need a Boolean value, right? It's either checked or not checked. So there's one class, runtime exception, that is, class exception. So there's a class exception that is the superclass of all exceptions.
So you just extend X.
A runtime exception extends that directly or indirectly. And if in your path you encounter class exception without hitting runtime exception, then you're checked. Otherwise, you're unchecked. Okay, and why is runtime exception a bad name? All exceptions are runtime. So what are you saying by calling some exception? It's a tautology, right? Every exception is runtime. They should have called it unchecked. And when I started teaching this stuff, I invented the word checked in my head. And now I Google it, and everybody else seems to have invented the same word. So this was the right term to have had. And they just called it runtime, and they're stuck with legacy code now. Okay? So a lot of people will call unchecked exceptions runtime exceptions because they're instances of that class, but every exception is runtime. Okay? Questions? So this is my hierarchy, which is what Zach was asking for. Exception is the top level there. And it's got many subclasses, IO exception, runtime exception, and so forth. And now, based on this, is class cast exception a checked or unchecked exception? Unchecked. And remote exception is a? And what do you guys think remote exception is? I'm going to look. Another program, distributed program, a remote program. Okay? So these are my unchecked exceptions, and these are my checked exceptions. Okay? The rule I gave you guys earlier. Okay? Questions? So in this example, I got this exception object and I didn't do anything with it. Okay, we type all these exceptions, we have, and I just ignore, besides the label, I just do instance of on the object. I really don't use any data here in all of these examples. Okay, and just let's try to go and imagine what are some of the methods an exception object might have that one could use. And I've already hinted what these methods might be. Get error string, exactly. It's called get message. And what other method I've hinted at? Get stack trace. Okay, so those are two important methods, and I can go here and say echo lines and say print line E. When I say print line E, what do you think the toString of E would be? Print line will call the toString method, and toString method would be the message. Okay, and here I'm going and okay. So what I'm doing here is basically implicitly I'm using the exception and I'm calling toString, and I'm printing the exception, which will print the message that we pass on the constructor. We saw that the constructor took a message as an argument. That same message will be printed out when we print out an exception. Okay. So in both of these cases, I'm now printing line. I'm being much lazier. Okay. I'm doing it for a reason. I'm just printing out the exception. I'm not giving any elaborate message. Yeah, Zach?
When it's thrown by, like, the compiler, I guess, like, is there a default message in the exception?
So when
Like, when you...
yes, when you don't throw the exception, when the runtime throws the exception, not the compiler, it will go and populate the message field with something, and that's the message field you guys have been getting when you got the exception. Fred, you had?
No, they're not.
Okay. Given that I want to just print the exception, given that, let's not debate whether that's a good idea or not. Can I make this code better? What's wrong with this code?
Well, a missing argument exception is an IO exception. It's doing the same thing.
And I'm doing the same thing. So could I replace it with one catch block?
Yeah,
And what would that catch be?
IO exception.
Okay, so this is the, if when you go and print out E, you get the E.get message. This is what I was saying earlier. And you get the type and the, so the toString is the message plus the type. I was wrong. It's not just the message you sent in. It is the name of the class plus the message. That is what the is. So okay, and I guess I asked that question a little prematurely. Now it's what I'm doing is I'm saying E.print stack trace in both cases. Okay, and we're going to get a stack trace. And what stack trace will this be, by the way? Sorry? Okay, so the main method was called, right? The main method called number of input lines. Number of input lines returned, an exception was thrown at that point, right? And it was caught back in main, right? So I had a stack before number of input lines was called. When the exception, then I have a stack when the exception was thrown, and then when I have a stack when the exception is caught. Which one of these three stacks will be printed out? Zach?
Is it when it's thrown?
When it's thrown, the catch knows at this point what the stack is. So why does it need to go and print it out? I mean, that information is there. What you want to know is you might be catching it 5 levels later, and you want to know where it was thrown and what was the stack at that point. And that is what you guys get when the interpreter prints out your stack trace. There is no stack. All the methods are returned to it. But you will get the stack at the point at which the exception is thrown, and you will go and see stacks that are this big when object editor throws an exception for you. You don't even know what's happening there. But I tell you guys, go send me the message because it gives me information about the exact line number and the method call. Okay? So it is that stack trace. So stack when exception is thrown, not when it is printed. Okay, and you'll get something like this. And this is what the interpreter will also do. And this is what you can do by having print stack trace. Okay? Questions? Okay, and now I'm going to answer the question that I asked earlier prematurely. And we can just say catch IO exception. And remember what this does, the code does. It goes and says, if E instance of this exception, do this. Else if exception of the instance of this exception, then do this. So both exceptions are typed by IO exception. So you can just have more uniform code here.
But if you wanted to recover and press like a subtype of the error,
If you wanted to do it,
certainly.
then you would do what I did earlier. I started with that you want to do something different. And then I went to something similar to show you that we can if we don't want to. You know how exception handling is used? I wish I could tell you something about that, but it's not clear. This stuff is pretty new. People don't even understand this properly, actually. When I was a grad student, I had to read papers to understand what exception handling was about because none of my teachers knew about it. And so I could learn from them, how to do this. And I'm not sure. I mean, the general principles try to recover rather than just detect. But, what are some more specific principles? I don't know if they exist or not. Okay? So I'm just telling you the rules right now. And you guys may be able to invent those principles. Okay? Really, I'm serious here. Okay. So a missing argument exception is a IO exception. Okay, let's say we don't care about, so let's say we want to do something different, okay, exactly what Keenan was saying. I want, in the case of IO exception, to print stack trace. In the case of missing argument exception, just print it out. Let's say I want to do it, okay. Would this work? Because everything would get captured right here. It's doing, is it instance of this, else instance of this. And could Java go and tell you you're doing something wrong here? Yeah, there's no complex code to be analyzed here. It just has to go and look at the order of the exceptions and see whether a subclass exception occurs before a supertype. Okay, so it will actually tell you unreachable code. Okay. Oh, I better remember to stop at 12:10. Okay, so this is what you want to do. You wanted the subclass exception to be before the superclass exception. Okay. Okay, let's look at this code. One of the exceptions here is array index out of bounds exception. Is there another kind of exception that you can that can be thrown here? Number format exception. Okay, and we can. So if we just do IO exception here, that number format exception will not be caught. Right, in the main method, the main method will cache the two IO exception, but the number format exception will not be caught. So if I want to go and print the stack trace even for number format, how should I change this code? So my main method would either get an array index out of bounds exception or IO exception. Yeah.
You could change the IO exception to exception is general, or you could, if you want,
Okay.
change it.
So I'm just being lazy, and I just say exception. That's the generic. Okay. So you're being you're being good. You're doing catching, but you're being as bad as you can be when you're being good. Right? You're being very general and say catch exception, and I do this all the time. Okay. So I don't know sometimes what to do, so I'm just going to print the stack trace and so this is something you could do, but if you can do something better and more specific, it's good. Okay, let me go to something apparently very different but related. When I'm initializing a variable, I could initializing an instance variable. I could initialize it when declaring the variable, or I could initialize it I thought, in a constructor. I thought I heard it. Okay? Okay, so I could have an undeclared variable and declare it in the constructor. What do you guys think? I never gave you a rule for this because I don't have a clue. Okay? What do you guys think is better? Constructor because? Sorry? No, you don't save memory. I mean, the variable is there. It's got one slot. What if you had 4 constructors and it had to be initialized the same way? Then the answer might be, while declaring it, unless all constructors call a common method. Yet somehow your instinct was constructor, right? Did you think any reason?
It's just what I've been doing.
This is what you've been doing? Okay, so I'm going to say that exception handling makes your answer the correct one. Can you see how constructor would be the right place to initialize something when you consider the fact that exceptions can be thrown?
You know 100% that whenever that class is actually that variable is non-null or 0.
Okay, so you're saying you'll get fewer exceptions if you initialized it while declaring it because you know 100%. That's a very subtle and it's a great answer. There's a more direct answer. So here I'm initializing it to a constant 5. Could I initialize it to something more complex? I could say 5 plus 6. Even more complex, what could it be? Sorry? Plus another variable, something even more complex? Could I call a function? Could that function throw an exception? In which case would the exception be caught? Could be caught. So let's go and say that I'm saying input.
Okay. Now, one issue that you probably faced. And
So I'm going and initializing this
given a
number
variable
by some
has to be
function call.
initialized to some value.
And this function
Should we
call
initialize
could
that
go
by
and
declaring the variable?
access an array index and
Or should we
use
initialize
that
that
array
with
index to or
do you guys
have a
think?
missing argument exception.
Initialize
This function
by
call could go
declaring
and throw an
in declare or
exception.
in the constructor?
If I did this, there's no catch block. Java can't go and insist that you have a catch block around it because there's no code around it.
In the constructor,
But if I go and do it in a constructor, then it can go and force you to catch the exception. Okay? So sometimes you are forced to do it in a constructor, and maybe if that function becomes, if that expression will later become a function that might throw an exception, maybe the approach of initializing in the constructor is a better approach
go to the
because
constructor,
it's
it'll
more
go to the
extended.
lines and we'll go through them and then we'll go to the constructor.
Okay?
So you can have an opinion here. The earlier the initialization,
So
the better.
Java will Okay. I promised you guys that we'll talk a little bit about the exam. So what are the rules? What does checked really mean? And what is unchecked? Unchecked means there's no rules. Up to you, what you do. Okay? No driving rules, essentially. Checked. If you don't catch the exception in the method body, okay? So you can always catch an exception. If you catch an exception, then your caller doesn't have to worry about it. You caught it. You haven't passed the buck. So if you are taking responsibility for the exception, then things are fine. But if you don't take responsibility, you have to acknowledge that in the method header, saying, it's my caller. I'm passing the buck. Okay? So if you don't handle the job, you pass the buck, you better tell your caller that you're passing the buck. Okay? That's the basic rule. This implies that if your method header says, method header does not mention that you are throwing an exception, that must imply that in your body you must be processing. Okay? Because from the first rule, this is what comes out. Okay? That if it's unacknowledged, then must be caught. And here's the interesting thing, that you have two headers for a method in a class. One is the header provided by the class. The other is the header provided by the interface. Okay? Now, if it is unacknowledged in interface header, that means it must be unacknowledged in the method, in the body, in the class header. Okay? So there's an interface method header and there's a class method header. If it's unacknowledged in the interface says, hey, we don't expect any exceptions to be thrown, then your class header better also say the same thing, which must mean that your method body has to catch it. So this is a roundabout way of saying that in the interface we can determine if the method must catch or not, or is required to catch or not catch the exception. So if I go and give you an interface which doesn't have throws in it, then it's your responsibility to catch it in the implementation. Otherwise, Java is going to complain. Okay?
So that means that you have to make the interface throws every possible exception that you're going to check. And you have to
See, you are the designer. Okay, so you're deciding that, I'm asking you to implement an interface. Okay, I have decided whether I'm going to process it. So if I don't want the buck to be passed to me, I put in the interface no throw space. That forces you to go and process it because Java will force you to do it as long as it's exception. So this is another way of saying that when I give you an interface, I can not only tell you what the parameters are, what the return type is, but I can also tell you whether you're responsible for catching the exception or not. It's a way to encourage modularization, or it's a way to not get the buck passed. It's not clear which is more modular. Maybe.
well, if you have an interface that's throwing exceptions, then probably is not
I don't know. Actually, if you don't throw exceptions, then you're down to a language without exceptions, which means when it's detected, it should be fixed. So if you have exceptions being thrown, then you're actually a more sophisticated program, because you're saying the caller can do something different.
Well, what I'm saying is if a single interface is throwing 50 different potential exceptions, then there's something wrong with the size and scope of your interface.
Could be. I mean, 50 different exceptions might mean there are 50 different things happening in one interface. So yeah. So maybe that's wrong. But it's whether a specific interface header says throws or not says throws is kind of independent of modifier. So interface can be used to force method implementation to catch exceptions. Okay, that's the moral here.
So we've seen. So we've seen. You can go, and I'm not catching it actually, and I should, but you can have a throws no such element exception, and so that would be, that's something you can say, and it's an unchecked exception. Okay. You can go, and I'm not catching it actually, and I should, but you can have a throws no such element exception, and so that would be, that's something you can say, and it's an unchecked exception. Okay. And here's something just to drive the point home, checked and unchecked. So now we've got an iterator that's actually a scanner also. Okay? So it's scanning user input to find the next line. Okay? So the next may be called when there are no lines left, or it may be called when there's some other form of IO exception. So it's got a no such element exception and an IO exception, and it's okay to say that because you're both doing input, which may cause an IO exception, and also next may be called when has next is false, and so it says no such element exception. So you can have both of these declared. need to return a value, and who knows what I should return. And in the absence of any other information, I want to say, look, I'll enter 0 because the number of input, I'm going to assume that the user enters nothing. It's 0. Okay, that's my guess. So I entered 0. Okay. Anybody, can you think of any other number that you could have also entered? That you return, that would also be reasonable? I mean, you could return any value. What else would be a reasonable value to return? So the user ran the program, right? And if they wanted nothing echoed, why would they run the program at all? So you can argue that maybe at least one, they really want at least 1. So you can make a guess that it may be 1. And the number of input lines doesn't know that it's being used to echo lines. So it can't guess the number 1. It doesn't even know this number is going to be used by echo lines. So it just returns 0 because of the context it has. But the main program, which knows better, could go and assume it's 1, or maybe there's some default of 2. So here is the situation where just the method that detects errors should not perhaps try to catch it. We should do custom handling, okay? But we don't want to do custom handling too quickly. And because we don't want to do custom handling too quickly, we'll complicate Java much more. Okay? And we'll have to try to figure out how to propagate exceptions. Okay? So we are trying to do error recovery. We are not halting the program. We are not saying exit. And if we are not saying exit, we have to return some value. So we return 0. And something else that's wrong here is that the UI code is mixed in the same method that does the computation. Okay, so that's something else that we'll try to see how we can overcome. And the reason why you don't want to mix things together is because you may do the UI in different ways. So that's a separate thing. You might want to create a message. You might want to create a pop-up box. Who knows what you would want to do? And you also want to go and maybe return a 1 instead of 0. But this method has no context to determine that it should be 1. So the moral really here is that your number of input lines quick in handling the error. What does it do? It says parse int arg0, and we can argue the same. We can make the sort of bounds exception. If that happens, you say did not enter an argument, and it says now what should I do? I have to return a value, or I can just exit the program. I can do one of two things. Okay, so we won't exit. We will return back to my caller. I don't know what value to return, so I'll return 0. Okay, this is my sort of recovery from error. Yeah, this is what I told you I'm not very good at. I still don't quite know how to recover from errors. Okay, but that's theoretically something you could do, and Java lets you go and do that. Okay, so you go and say return 0. Okay, so you see again an example of try catch, where you're catching this. And by the way, is that the only error that can occur here? That the user didn't enter an argument? Nasha? You guys are experts at that right now, right? So you could have trouble, they may not have entered 5, 6 or some digit sequence. They may have entered something else. So is this a function or a procedure? Have you guys tried when you have if-else's in a function, if the then part returns a value and else doesn't, what does Eclipse tell you? Return a value, return a value. It's very good, right? So if you're going to return, you better go and, if you're going to not exit, you better go and return. Okay? They used to say, there's a guy called Dijkstra, he's just recently died, unfortunately, and he spoke his mind. And he had all these theories about basic, Fortran, and other languages. And he used to say things like, this language corrupts the mind beyond repair. The teaching of this language should be considered a criminal offense. Okay? And from what little I've seen of JavaScript, so it's a language I try to avoid, we can say the same things about that. I mean, I saw my friend, Jasleen, who's teaching from that, and you know that apparently if you don't declare a variable and you just misspell it later, you just think it's a different variable. And you sit down with the student, and I say, well, why are you always helping students that much? And that says something about me. And she says, I have to help them with all these syntax errors that you get no feedback from in JavaScript. Okay, so learn Java, learn how to do it right, and then when you really know what's going on, at that point, you know, you're probably licensed to program in JavaScript. But yes, you can do fancy web applications, and you know that's all.
Now, in your specific example here, in the event that number of lines, the echo line method, it's going to take an integer, and in the event that you pass it 0, it's not going to do anything because you told it, I don't want it. In the event that 0 had some sort of real meaning to that program, aside from assigning it some other error value like a -1, could you throw an exception?
That's what we'll get to that, especially in a method. So you can either exit, or you can return a value, or you can throw back an error. You can return an error value. That's the neatest thing about exceptions. Okay. So right now, firstly, this is not a very good thing because you're returning 0. You know, the user ran the program. They didn't enter any argument. Now, what's the default number you should choose? You can use 0, or you can choose -1 is something you use again when you don't have exceptions. Okay, so you say, okay, 0 is the legal value, so I'll return an illegal value, so that the other person knows there was an error. So that the other person, my caller, can recover. So if you return -1, the caller could say, okay, you, number of input lines, you don't know what's going on. You don't know how it's going to be called. You don't even know there's an echoing going on. Okay? You're just returning number of input lines. So it's just the caller, the main guy, who knows what's going on, that he's putting number of input lines and echo lines together. And they should perhaps make the decision as to how many lines we should use as default. And this is probably a bad decision, that we might want it to be 1. Okay? Because, you know, the person ran the program, give him at least one chance to, you know, input 1 line, or maybe there's a default number 5. You know? So there are few things going wrong here. Even though we are doing this exception handling, we're returning a value that may not be the best value to return, because we are some method that's being called by some other methods, and we don't have enough context. So our caller has more context than we do. So you want to pass the buck. Okay? So passing buck is actually good in exception handling. Okay, you don't normally think of that because you're saying there's separation of concerns, and I don't have enough information, and I just found the error. I don't want to report. Who knows how to report anyway? So you pass the buck to your caller. Okay, so that's what you do. You basically return an exception. So UI mixed in computation code, which is kind of what I was hinting at. Okay, I didn't pass the buck. I want to do it myself, which means I'm doing maybe more than I should. Okay, and the program is not halted. That's probably good. And I guess I should have said debugging too. Okay, so these are the general principles, and now we're going to see how these principles translate into exception handling. Okay, so one of the things they do is give you typed errors. You don't just get core dump. You get to know this kind of exception happened or another kind of exception happened. What are some examples of exceptions you've seen perhaps? That, you know, Java told you about, that you didn't, null pointer exception. Anything else? Index out of bounds exception. Okay, so we have types. Okay, so you can customize the error handling. I just said you can do, your error processing can be more efficient. Okay, that's what really efficiency meant here. Allows separation of concerns, modularity. Your error handling code can be easily separated from your non-error handling. Okay. And why might that be useful? If you're trying to understand somebody else's program, why might it be useful that you can separate these two things out? So when you're starting out and you're debugging, you might want to look at the error handling code. And if you're not debugging, if you're just trying to figure out what this program does, maybe you'll not look at the error handling code. Okay, and say, let me just see how the program works first. Then I'll try to figure out the boundary conditions. Okay? So you might want to, maybe if you're a security person, you'll be looking at the errors and saying, where are they going wrong? If you're just trying to add a new feature, you might go and look at the non-error handling code and say, you know, the security guy's worrying about this, I'm going to worry about it. Okay? So you can easily separate, you can easily tell which is error handling, which is not error handling. And also you can put these codes in different classes and methods so that you can change one without the other. Okay? You might want to go and have the error message in English once or in another language later, and keep adding different languages. And so, you know, you want that to be in separate classes so that the person who's expert in that language can focus on just the on just that particular class and no other code. Okay? And so the user interface for errors is also an issue, and you can have separate classes that do this. So now you see why exception handling is important. Okay? That you can do exception handling without Java exceptions, but it just makes it easier to do these things. Okay, and these are just regular software engineering principles being applied to error handlers. Okay. Questions so far? Okay. Okay, so that's a rule. Now you can go and say throws array index out of bounds exception. That's allowed. It's not required, but it's allowed. And can you guys think about the car analogy that, actually, I kind of put it here. So, you know, if you're a new driver, you're required to go and say you're a new driver. But are there other things people put on cards to say that, hey, something bad may happen, watch out, which are optional? Baby on board. Very good, very, very good. I was showing my age when I was talking to Ben about a thing, and you guys might not even have seen this. But you guys, are there still signs like this? They were very popular, and one that was really popular was this one. So anyway, so these are optional warnings. You can always say throws array index out of bounds exception, okay, but you don't. You know, so the one question is, what do you do with exceptions? I can tell you all these lovely rules, okay, and they make sense. And what do you do when an exception arises? Okay, and what do people do? Or at least what do I do and lots of other people do? So you see two common responses to exceptions. And what is the first one doing, you think? So it's going to, println is going to take an object which is a type exception, and it's going to look for e.toString. And e.toString is going to return what? Something that's peculiar to exceptions. Okay? There's a method called getMessage in an exception, and e.toString will simply go and print e.getMessage. Okay? And what do you think the next one is doing? I mean, the English is pretty clear. Yeah. So it's printing a stack trace. We know that for sure from the English. And there are two stack traces at this point possible. One is a stack at the point at which this statement is being executed. And the other is a stack at the point at which exception is thrown. Okay? And it's going to do the first one. Because you know where you are. The guy who's printing knows where he is. The guy who's printing this can then go and figure out where it was. And do you think this is a useful thing to have? You guys have found it useful? When you report object editor errors to me, and you give me the stack trace, do you think I find that useful? It says null pointer exception. It tells me exactly where that line is. I just go to that line from my editor and say, this is where I don't check for null. Let me put a null check. Okay? So this is very useful. Much better than the core dump that C throws at you, which I talked about. Okay? But the baby on board is an excellent example. Okay, so now that we understand that they're checked and unchecked, let's look at some code we know about. Iterator. Has next and next. Any bad thing can happen here? This code works, we know. or let's assume it works. Yeah.
You were to call next, given as next false.
So bad things can happen at that point, right? So let's assume that bad thing is an exception. Okay, and that exception is a no such element exception. That when you call next and there is no element left, there is a no such element exception which Java defines that can be true. Okay? Should that be checked or unchecked? You have a way to avoid it by calling has next. Okay? So no such element is an unchecked exception, and we haven't gone and said it throws that exception. But it could if you don't do. Yes, Willem? We're assuming there isn't. I mean, actually, in this case, it's just going to go and give the character. Yes, there is. But it's not a letter. Okay? So we should be actually, if we were really good, we should check that and go and throw that exception. Because Java is not going to throw an exception. Yeah. I just threw this example in because it was simple. But yeah. Okay. But you can go, and I'm not catching it actually, and I should, but you can have a throws no such element exception. And so that would be, that's something you can say, and it's an unchecked exception. Okay? You can go, and I'm not catching it actually, and I should, but you can have a throws no such element exception, and so that would be, that's something you can say, and it's an unchecked exception. Okay? And here's something just to drive the point home, checked and unchecked. So now we've got an iterator that's actually a scanner also. Okay? So it's scanning user input to find the next line. Okay? So the next may be called when there are no lines left, or it may be called when there's some other form of IO exception. So it's got a no such element exception and an IO exception, and it's okay to say that, because you're both doing input, which may cause an IO exception, and also next may be called when has next is false, and so it says no such element exception. So you can have both of these declared. Okay. And here's something just to drive the point home, checked and unchecked. So now we've got an iterator that's actually a scanner also. Okay. So it's scanning user input to find the next line. Okay? So the next may be called when there are no lines left, or it may be called when there's some other form of IO exception. So it's got a no such element exception and an IO exception, and it's okay to say that, because you're both doing input, which may cause an IO exception, and also next may be called when has next is false, and so it says no such element exception. So you can have both of these declared. And here's something just to drive the point home, checked and unchecked. So now we've got an iterator that's actually a scanner also. Okay? So it's scanning user input to find the next line. Okay? So the next may be called when there are no lines left, or it may be called when there's some other form of IO exception. So it's got a no such element exception and an IO exception, and it's okay to say that, because you're both doing input, which may cause an IO exception, and also next may be called when has next is false, and so it says no such element exception. So you can have both of these declared. Okay? And here's something just to drive the point home, checked and unchecked. So now we've got an iterator that's actually a scanner also. Okay? So it's scanning user input to find the next line. Okay? So the next may be called when there are no lines left, or it may be called when there's some other form of IO exception. So it's got a no such element exception and an IO exception, and it's okay to say that, because you're both doing input, which may cause an IO exception, and also next may be called when has next is false, and so it says no such element exception. So you can have both of these declared. And here's something just to drive the point home, checked and unchecked. So now we've got an iterator that's actually a scanner also. Okay? So it's scanning user input to find the next line. Okay? So the next may be called when there are no lines left, or it may be called when there's some other form of IO exception. So it's got a no such element exception and an IO exception, and it's okay to say that because you're both doing input, which may cause an IO exception, and also next may be called when has next is false, and so it says no such element exception. So you can have both of these declared. Okay. And here's something just to drive the point home, checked and unchecked. So now we've got an iterator that's actually a scanner also. Okay? So it's scanning user input to find the next line. Okay? So the next may be called when there are no lines left, or it may be called when there's some other form of IO exception. So it's got a no such element exception and an IO exception, and it's okay to say that because you're both doing input, which may cause an IO exception, and also next may be called when has next is false, and so it says no such element exception. So you can have both of these declared. Okay. So what are the rules? What does checked really mean? And what does unchecked? Unchecked means there's no rules. Up to you, what you do. Okay? No driving rules, essentially. Checked. If you don't catch the exception in the method body, okay? So you can always catch an exception. If you catch an exception, then your caller doesn't have to worry about it. You caught it. You haven't passed the buck. So if you are taking responsibility for the exception, then things are fine. But if you don't take responsibility, you have to acknowledge that in the method header, saying, it's my caller. I'm passing the buck. Okay? So if you don't handle the job, you pass the buck, you better tell your caller that you're passing the buck. Okay? That's the basic rule. This implies that if your method header says, method header does not mention that you are throwing an exception, that must imply that in your body you must be processing. Okay? Because from the first rule, this is what comes out. Okay? That if it's unacknowledged, then must be caught. And here's the interesting thing, that you have two headers for a method in a class. One is the header provided by the class. The other is the header provided by the interface. Okay? Now, if it is unacknowledged in interface header, that means it must be unacknowledged in the method, in the body, in the class header. Okay? So there's an interface method header and there's a class method header. If it's unacknowledged in the interface says, hey, we don't expect any exceptions to be thrown, then your class header better also say the same thing, which must mean that your method body has to catch it. So this is a roundabout way of saying that in the interface we can determine if the method must catch or not, or is required to catch or not catch the exception. So if I go and give you an interface which doesn't have throws in it, then it's your responsibility to catch it in the implementation. Otherwise, Java is going to complain. Okay?
That means that you have to make the interface throws every possible exception that you're going to check. And you method.
See, you are the designer. Okay, so you're deciding that, I'm asking you to implement an interface. Okay, I have decided whether I'm going to process it. So if I don't want the buck to be passed to me, I put in the interface no throws. That forces you to go and process it because Java will force you to do it as long as it's exception. So this is another way of saying that when I give you an interface, I can not only tell you what the parameters are, what the return type is, but I can also tell you whether you're responsible for catching the exception or not. It's a way to encourage modularization, or it's a way to not get the buck passed. It's not clear which is more modular. Maybe.
Well, if you have an interface that's throwing 10 types of exceptions, then probably is not
actually, if you don't throw exceptions, then you're down to a language without exceptions, which means when it's detected, it should be fixed. So if you have exceptions being thrown, then you're actually a more sophisticated program, because you're saying the color can do something different.
What I'm saying is if a single instance is like 50 different potential exceptions, then there's something wrong with the size and scope of your interface.
Could be. I mean, 50 different exceptions might mean there are 50 different things happening in one interface. So yeah. So maybe that's wrong. But it's whether a specific interface header says throws or not says throws is kind of independent of modifier. So interface can be used to force method implementation to catch exceptions. Okay, that's the moral here.